Hey guys, welcome back to another session by Simplilearn. Today's topic of discussion is Java versus Python. So in this session, we're going to compare the two most prominently used languages, that is Java and Python. We're also going to help you choose the appropriate programming language depending on your requirements. If you haven't subscribed to our channel already, I'd really suggest you hit the subscribe button and the bell icon to never miss an update. Alright, I'm sure we've all been in this position where we've had to choose between Java and Python. And it was so confusing. So today, let me help you choose between the two languages and look at what's in store for us. First, we'll have an introduction to both Java and Python. Then, we will compare the fundamental concepts of both these languages. After that, we will get to know the various fields in which these languages are being used extensively. Then, we will go through the current industry trends and the salaries offered to these developers. And finally, we will reach to a conclusion and decide for ourselves which language is good for us according to our requirements. So let's start the session by first getting to know both Java and Python. Java was developed by Sun Microsystems. It is a fairly robust and high-level language. It is an object-oriented language and so adheres to all the OOPS concepts like abstraction and encapsulation. It was originally designed for use in small hardware like set-top boxes and handheld devices, but due to the increasing popularity of Internet in those times, it was very quickly modified to be used in the World Wide Web. Moving on, what exactly is Python? Now you won't believe this, but Python was created in the year 1989. Like Java, it is also object-oriented and is a high-level language. It incorporates many English words in its syntax as it was designed to be significantly more readable than other programming languages. It is mainly used for artificial intelligence, machine learning, and web development. So now that you've been introduced to both Java and Python, let's go ahead and compare the fundamental concepts of both these languages. First up is speed. Java is a statically typed language, which means the syntax is checked at compile time and so the execution speed is faster. Oppositely, Python is a dynamically typed language, so the syntax is checked at the time of execution. This makes the execution speed slower when compared to Java. Next up is syntax. Python has a clear advantage when it comes to the amount of code we have to write for performing the same task. You can point out how simple it is to print a hello world in Python when compared to Java. Python automatically sets the type of variable according to its value. Java, on the other hand, needs the type of variable to be defined before the compilation of the code. Java is more commonly used for web and mobile applications, while Python is mainly used for data science, machine learning, and Internet of Things. I'm sure by now you have a good understanding of these languages. So let's go ahead and see where they're used more commonly. First up, let's see the use cases of Java. It is commonly used for developing web and mobile applications. Java is extensively used in enterprise applications because of its stability and also because of the large number of features that it provides for business applications. Android applications are mainly developed using Java. Now let's see the use cases of Python. Python is very popular for the use in the field of artificial intelligence. It is also used for web development, mostly for the backend part of an application. YouTube is mostly written in Python. Moving on, let's go through the industry trends and salaries for both Python and Java developers. The graph represents the growth of both the languages over the last 5 years. We can make out that Python has picked up over time and has become more popular than Java in recent times. This is mainly due to the increasing popularity of data science fields. Moving on to the salaries. The average salary of a Java developer in India is around 4.5 lakhs per annum. The average salary of a Java developer in the US is around $80,000 US. Moving on to Python, the average salary of a Python developer in India is around 4 lakhs per annum. Since people pursue Python mostly because they are interested in the field of data science, the salary dramatically increases when they get a suitable role, say data scientist. Data scientists get paid on an average of 10 lakhs per annum. The average salary of a Python developer in the United States is around $76,000 US. If they get into data science roles, their average salary spikes up to around $110,000 US. Moving on to the last topic on our agenda, here we conclude as to which programming language is suitable for you depending on your requirements. Let's now think about why we'd want to go with one of these languages. Here are some points to keep in mind. Choose Java if you are more into software engineer roles and want to handle systems for large corporations. Java is extensively used for developing Android applications, so if you want to build an application for Android OS, Java should be your clear choice. Java is also suitable for building various standalone end-to-end softwares that run on the PCs. If you are into this sort of thing, then Java is the language for you. On the other hand, if you're interested in the fields of artificial intelligence, data science, or the Internet of Things, Python is the go-to language for those sorts of technologies. Python is very simple to understand, so if you're learning to code for the very first time, I'd suggest you go with Python. If you're interested in web development, Python can be a good choice as it provides excellent frameworks like Django and Flask to facilitate web development.
In today's era, the internet and smartphones have become an integral part of our lives. We use our phones for almost all of our day-to-day tasks. Earlier, we used to shop at malls, queue up in front of banks, and make our travel bookings at travel agencies. But now, we can do all this in the comfort of our homes using smartphones. All of this is possible because of a high-level programming language called Java. Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, servlets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to bitcode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. each button on the remote performs a different task. Methods in Java are the same. We can have methods to add two numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in 2 different places where their tasks will differ.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So now let's download Java. Let's go to Google and search for Java download. We'll go to the link we see here, oracle.com. So now here we have the web page. Here we can see Java SE 13. So this is version 13, but this isn't the one we are going to download. We are going to download the 8th version, version 8. Which is here. Now we're doing this because 8 is one of the more commonly used versions of Java. So let's click this, and here we'll go down. We need to accept the license agreement before we can download it. Now we have 2 versions here, x86 and x64. Now you can download it depending on what version your operating system is. Now if you do have a Windows 10 operating system, it's highly likely you have a 64-bit version of Windows. Now if you do have a 32-bit version of Windows, you can take the x86. So let's download this. So we've actually already logged in, so we just need to run the installer file now. Let's go to downloads and run the file. So here we have the installer. We'll go to the next step. We'll select this to next. Here we can see where the file is being installed to. We'll go to next. Now if you want to change where you want to install Java, we can press the change option. I'm just going to keep it here. We'll press next, and let's commence with installation. And there we go. The installation is now complete. So we don't need any tutorials or API documentation. So we'll just finish off and go to close. Now to see if Java is installed in your system, we can go to command prompt and type the term javac, which refers to the Java compiler. Now, as you can see here, this shows a number of different options you can choose from. This also indicates that Java has been successfully installed in your system. Now, if the installation was not successful, you'll see something like javac is not recognized as an internal or external command, operable program, or batch file. But since we've done it successfully, this is what will be shown. Now we're going to set an environment variable. Now, what exactly is an environment variable? Now assume you have a file which has a .java extension. This environment variable tells the computer that the Java program needs to be called to run this particular file. So to set the environment variable, we'll need to go to Control Panel. Here go into System and Security. Go to System and select Advanced System Settings. And then this shows up. Now before we go into environment variables, we'll need to go to where the Java file was installed. So let's go to this PC, C drive, program files, and here let's go to Java. So let's go to JDK, which is the Java Development Kit. Let's go to bin here and copy this path. We'll go back to environment variables, select path here, and then press on new, paste this, and OK. Now we'll go back and go to JRE, to the path of JRE, which is Java Runtime Environment. We click on this, then again, and copy this path. Select this one, new, and paste that. And there we go, the environment variables are now set. Now let's talk about running that simple program I told you about. Now this is possible with the help of an IDE. An IDE, or Integrated Development Environment, will give us a platform to code Java. We will be using Eclipse and IntelliJ as they are popular and commonly used. That being said, there are several other IDEs that are available in the market. So now let's work with Eclipse. Let's go to Google and search for Eclipse. We'll go to this link, press download. And then this shows up. Let's click on download. Now we've already downloaded the software, so I'm just going to directly go into the install phase. Downloads and select Eclipse. With this, you can see that there are multiple options for you to choose from. So we're going to select Eclipse IDE for Java developers. Now you have other options like for C and C++, JavaScript, PHP, and so on. But let's go to the first one. And here you have the details. You can change them if you want. But I'm just going to go ahead with installation now. Press accept now. Here we remember accepted licenses and press accept. And then here as well, we'll remember accepted certificates. Select this one and accept selected. And there you go, the installation is now complete. Let's click on launch now. So here we are setting up a directory as a workspace. I'm not changing it here, so I'm just going to go with launch. Here we have the Eclipse workspace. Now let's close this first. And here we have the package explorer. Now in case this doesn't show up, you can go to window, show view, and select on package explorer. So now let's go to file, new, and Java project. We need to set up a project name. I'm going to call it my project 1. Go to next. We'll go to source. So this is where the source code for your program is going to be stored. Then let's finish. And now we'll click on my project 1, go to source, right click, new, and create a class. I'll name the class my class and create it. And here we have it. So now let's write a simple program to multiply two numbers. So now let's write the main function. Open bracket. Now we're going to initialize the first number. Now the second one. And finally the output. And finally the variable that will store the output. Now we'll just give them a simple print statement. Now let's run the code by clicking this option here, using myclass.java, and there we have it. Here the product is shown to be 100, indicating that the program is running successfully. Now we're done with Eclipse. Now let's move on to the other IDE I was talking about, which is IntelliJ. So for that, again, we'll have to go back to Google so that we can download it. How to install Eclipse IDE on your Windows 10 operating system. Now an IDE is an integrated development environment. On this, computer programmers can perform software development. Now Eclipse is one of several in the market like IntelliJ, BlueJ, Dr. Java, and so on. Now to install Eclipse, first you need to install Java. This is because if you try to run the Eclipse installer, this shows up. This shows that you do need Java before you can install Eclipse on your operating system. So first let's go and download Java. Now let's search for Java install and then go to this link. Now here we have the latest version, which is version 13. We're not going to pick that one up. We're going to go to version 8. Now we're choosing version 8 because this is one of the most commonly used versions of Java. So let's select this. So we'll go down all the way here, and here we can see two options, the 64-bit and the 86-bit. So this basically represents the 32-bit operating system. So if you do have one, you can select this option. Since we have a 64-bit operating system, I'm going to select this. But before the installation, you need to accept license agreement and select this. Now I've already logged in, so I'm just going to install now. Let's select this, go to downloads, click on this. And then this shows up. We'll go to next, and let the install complete. So here we have another pop-up. So if you want to change the destination folder, you can select this option. This is fine with me, so I'm going to go with next. That's it. We'll let the installation complete now. So there you go, the installation is now complete. So if you want to look at tutorials or documentation, you can go to the next steps. I don't want to, so let's close and go back. Now just because we've installed Java, we can't exactly run it yet. For that we need environment variables. Now environment variables help the computer understand that it needs to run Java when it sees a .java file. For that, let's go to the control panel. Let's go to system, and then let's go here and select advanced system settings. And then this shows up. Now before we can set the environment variables, we'll need the path to where Java is installed. So let's go to File Explorer. Let's click C drive. Let's go to Program Files. So this is where I install Java. Let's go to Java. First, let's go to JDK and bin. Now let's go back here. Click on environment variables. Select a path here. Now go back. Let's copy that and press on new and paste this. Now likewise, let's go back. Go to JRE, which is the Java Runtime Environment, and JDK, which is the Java Development Kit. Click on this, go to bin, and select this path. Go back, go to path, select new, and paste this as well. And there you go, the environment variables are now set. Let's click on OK, and that's done. Now let's install Eclipse. Let's go back again and search for Eclipse. In here, select this option, click on download, select 64-bit. So and this shows up. So I've already downloaded it, so we can directly go there. I'm going to click on this now. So now we have the installer show up. So here you can choose from a number of different options like C, C++, PHP, and so on. So you want this one, we'll click on this, and here we can just install. We'll accept, and there you go, the installation is going on right now. We'll remember accepted licenses, accept this. You need to accept these certificates, accept selected, and there you go, we're complete. Let's launch. So now we need to set up a directory, so I'm okay with this, so let's launch. And there you go, here's the workspace. So let's run a very simple program now. So we'll close this, and here you have the Package Explorer. Let's open this up. So in case you can't access the Package Explorer, go to Window, click on Show View, and select Package Explorer. Now first, to run a program, you need to create a Java project. Click on this, and let's name our project. Let's go to Next. And here you see SRC or source. Now this is where the source code of your program is. Now we'll just finish, and that's that. Now we go to source, right click, new, and create class. Now let's create a class 1, and finish. And now we should be able to run any program we want. Let's look at the very simple code of writing hello world. So let's open the main function. There we go, let's open a bracket. Here, let's print. And that's that. Now let's run the program by clicking on this icon. Let's select the class, and there we go, we have an output. This means the program is running successfully.
Let's begin with the fundamentals. So the first one in the fundamentals is the data types. So every programming language has a data type. So what exactly is a data type? So whatever the input you provide in your program is a data type. For example, if you provide numbers, so in that particular numbers, we have a different variety of numbers. If you are giving just 1, 2, 3, so on without a decimal number, then that particular type of input, which is a number, will be considered as integer type. If you provide the same number with a decimal point, then that will be considered as float. And if you have the range greater than float, it will be considered as double, and so on. So this is how we have multiple data types in every programming language. So the most frequently used data types in Java programming languages are as follows. At first we have the byte, followed by that we have short, int, long, next float, then double, boolean, and finally char. Apart from this, we also have few other data types, but these are the most frequently used ones for all the basic programmings. So this is made for beginners basically. So you can take a quick screenshot of this particular slide so that you can have a quick overview or reference to all the data types in Java programming language. So I hope you have taken a screenshot of this. Now let's begin with the next concept. So in the next concept, we have the keywords and variables. So all the programming languages have variables and keywords. So variables are used to store the values. So for example, consider that you wanted to run some arithmetic operation on two different values, that is 5 and 10. So in order to do so, you might want to create a variable which stores them. For example, you wanted to store the value of 10 in a certain variable A and the 5 in a certain variable B. So if you apply the arithmetic operation, that is A is equals to A plus B, then the value of A, which was previously 10, will be updated to 15. So here you can see the value is varying, and also it is storing the result. So this is why the variables are used in a program in order to store a value, and this particular term variable is used because the value can change at any instance of time once after a certain arithmetic or a logical operation is performed on that particular variable. So similarly, we have keywords. Unlike variables, keywords have a special meaning. No matter whatever you try, you cannot change the meaning of that keyword. For example, consider main. So you cannot use the term main for normal things because the part or the term main is dedicated for a different purpose. So whenever you try to execute your Java program, the control flow will start executing the program right when it reaches the term main. So it has a special meaning. Similarly, you have other keywords such as int, so that is dedicated for integer type of values, and float for float type of values, that is the decimal values, and byte for byte, char for character type data, string for string. So every keyword or every term with special meaning which is predefined and cannot be changed is called as a keyword. Now let's see the most frequently used keywords in Java programming language. So similar to the previous one, we have a table here. So in this particular table, we have the most frequently used keywords in Java. So you can see we have boolean, final, byte, native, and we have void, switch. So switch is a conditional statement. So we have if it is also a conditional statement. We will go through these conditional statements as we proceed in our tutorial. And you can also see the protected. So this term, which is protected, public, so this is basically the access modifier. Even this particular keyword have special meaning. This public, this protected keywords provide the information to the compiler or the interpreter about the accessibility of that particular data member or data manipulating method. So if it is protected from your accessibility or is it available for you, it's provided by these keywords. So we will deal with access modifiers in the upcoming parts, don't worry about that. And as you can see, we have implements, extends. So extends, this term comes in inheritance. So inheritance is one of the crucial concepts of object-oriented programming. You can also see abstraction. So this we will be dealing in the next upcoming part where we will understand the object-oriented programming concepts. Next we have interface, return, and so on. You can also see some keywords like throw. So throw will come in exception handling. So we will also learn about exception handling in the upcoming part. So these are the most frequently used keywords in Java. So now we will move ahead into our next concept. So the next concept is the operators in Java. So to understand operators, let's go through a table. So on my screen, you can see a table which has some arithmetic operators which are most commonly used, that is the plus for addition, minus for subtraction. Similarly, we have star, forward slash, double plus, double minus. So double plus and double minus say they are increment and decrement operators respectively. As you can see, we have a plus plus here, which means the post increment. So the first value will be read, after that the value will be updated. Next we have the pre-increment, the value will be incremented first, then the updated value will be stored. So that's how the increment and decrement operators work. So we have the modulus over here. So to understand the operators that we use in Java in a much better way, let's try to execute a sample program. So on my screen you can see a program which is based on operators. So we are currently on the Eclipse IDE. Don't worry about the IDEs and Java, etc., etc. So I will drop a link in the description box below which will explain you in a very detailed way about how to install Java into your local system and how to install Eclipse IDE in your local system, and also how to create your first project, how to create your package, how to create a new class, how to write your program and how to run that, how to see the output, and a complete overview of the Eclipse IDE, how that works. So everything will be linked in the description box below. You don't have to worry about that. So right now, to save time, I have created the text document which has all the programs that we will be executing today. So I will also drop a link for that particular file so that you can have complete access to that file, so that you can run the programs in your personal PCs or laptops and also understand the programs in a much better way. So now let's begin with the program. So this particular program is basically designed for arithmetic operations. So you can see we have the operators, that is the addition, subtraction, multiplication, division, modulus, and exit. So basically we will be taking input from you. So the input will be taken by the user. That is, we are using scanner class here. So scanner class takes the input from user, and that particular input will be compared here. So we are using the switch case here. So if you provide the option as 1, then addition operation will be run. Similarly, second for subtraction, third for multiplication, fourth for division, fifth for modulus, and sixth to exit. So this is how the loop or the program works for arithmetic operations. Now let's quickly run this program and see the output. So you can see the program got successfully executed and we have the console asking for the first input. Let's provide some random number. Now let's provide the second number. So there you go, we have our options over here. Now let's choose division operation. For that you need to provide the number 4. So there you go, we have the result over here, which is 4. Now the loop has started once again. Now it's in the starting stage again. It's asking for numbers. Now let's provide a 25 and 5. Now let's choose some operation, that is addition. So for that you need to provide 1. So we have the result again, that is 30. Now let's again choose some number, 10, 5. So basically that's how the program works. So we have the brief idea how the program is running now. So now let's quickly continue with our next topic. Now to terminate this loop, you can provide the option number 6. So we have terminated it. So I hope you understood how the program flow is running. So if you did not understand, don't worry. I have linked the document in the description box below. You can take the access of that particular document and you can check the program and run in your local system, and also you can make some modifications to it. As you can see, we don't have a default case over here. I've just placed the case 1 to 6 and I'm saying the default because you can see that the options are from 1 to 6. What if the user provides the number as 7? Right? So the program might crash over here. So for that purpose, you can write in another case that would be the default case. So the default case will check if the number is anything above or out of the range of 1 to 6, then it should be providing you with an output saying a wrong input has been given, or check your input, or something similar. So that's how you can make some modifications to it. You're free to modify the code as well. Don't worry about that. So now let's quickly begin with our next concept. So in the next concept, we have the conditional statements. So what are the conditional statements or the control statements? So basically these are these are conditions. So what happens is, just imagine that you wanted to do something, or if you wanted to drive a vehicle, or if you wanted to drive a bike. So the condition you will apply on your mind is, if I know driving, then I will do it. If not, I'll not do it. So that's what you do, right? So basically you apply a condition on your mind and you do it if it is capable of doing, or if you are capable of doing it. So in the same way, the conditional statements play a major role in computer logic. So before writing a code or before you start your program, you provide the condition. Perform this particular operation if the provided condition is satisfied. So similarly, you have these 3 conditional statements in Java, which are if else, and nested if. So we use these conditional statements in Java to implement our logic. So we will understand the conditional statements, particularly if if else and nested if in a much more detailed way by practically running some programs based on these three types of conditional statements. So now you can see that we are back on the Eclipse right now. So this particular code segment is based on the if condition. I hope the program is visible. Let's try to increase the font size. So I think it's better now. So basically we have an input. So we have the integer type of input, that is num, and we have the number as -100. So it is a negative number. And after that we have the if condition. So this is where the conditional statement is provided. So the condition is if the number is greater than 0. If the provided number is greater than 0, then the control should enter the loop, which is this particular segment, and execute the statements present inside that particular loop. So here we have one single statement, that is a print statement that says the number is positive. In case the condition fails, imagine that the condition fails, then what happens is that instead of entering this particular code segment, the control will skip and execute the next statement, that is another printf statement which we have over here, which says the if condition is terminated, control is outside the condition block. Now since we have provided a negative number, the second option should go ahead. Now let's try to run this and see the output. So there you go. As expected, the program got executed and we have only one statement, that is if condition is terminated, control is outside the block. Now let's try it otherwise. Let's just eliminate the negative number and now check it again. There you go. Now you can see the program got executed and now we have two print statements. You can see that the condition here was true, so the control entered into the statement or the code block and this particular statement got executed successfully. Once the statements are executed and there is nothing else to do, then the control will automatically exit this particular statement and it will enter into the next statement, which is another printf statement, and we have the same output over there. So this is how the single if statement works. So you can also modify this with an else. So that's the next program that we are going to see. We are going to execute some similar kind of example for our next kind of conditional statement, that is if else. So here only we had one if condition. So in case if this particular condition fails, then we will be having another condition over here, which will be the else block. So as you can see, we have another program. So this particular program is based on if else condition. So here you can see that we have our first if condition, which states number should be greater than or equals to 0. If this particular condition is true, then this statement should be executed, which says the number is positive. Else, if this condition fails, then what you must do? The control should avoid entering this particular segment and it should directly hit the next segment where we have the else block, which has another statement which says the number is negative. So this is how the program works. So here we will be doing a little modification over there. Instead of taking an input which is previously defined as it was in the previous example where we had given -100 previously, we are going to do it a little differently. This time we'll be taking or reading the input directly from the user. So for that we are going to use this scanner class. So this is the particular library that we will be using. So we have imported java.util.scanner. So this particular code segment will ask you for the input and you will press some random number and it will read it as its input. Now let's try to quickly run this program and see the output. There you go. The program got successfully executed and now it is asking for an input from the user. Now let's try to provide a negative number. So there you go, the program got successfully executed and you can see that since we had given a negative number, the control did not enter this particular code segment at all. It directly avoided to enter this code segment and entered into the else block and executed the statements present in that particular else block, which was a simple print statement that had the statement which read as the number is negative. Now let's try to execute the same program again and see what would be the output. So there you go. Now it's asking for the input again. Now this time let's provide a positive number. So there you go. Since we provided the number as a positive number, this condition was true and this particular statement got executed. Since one of the statements executed, there was no need for the else block to be executed again. So you can see this particular code segment runs in this way. So once the condition is checked, so if the condition is true, then the true statement will be executed. In case if the condition's result is false, then the false statements will be executed. So you will be provided with two options. So one option for true validity and another option for false validity. So this is how the if-else block works. I hope you understood this. Now with this, let's continue with the next type of conditional statement, that is the else-if ladder. So on my screen you can see there is a change of program. We have stepped into the next type of conditional statement, that is the else-if ladder. So basically everything will be same. We will be provided with only one condition. So we will be checking the validity of that particular condition. So if the provided condition is true, then the first one will be executed. If it is not, then the second one will be executed. If the condition fails for the first two, the third one will be executed. If the first three fail, then the fourth. And if all the four fails, then we will have one last else which will print the last segment or statement. So this is how the else-if ladder works. So basically it's completely similar to if-else, but the only difference is instead of one else block, we have multiple else blocks. That's the only difference. Now let's quickly execute this program and see the output. So basically we are going to take an input from the user. So we will be entering 1 for noodles, 2 for milkshake, 3 for fruits, 4 for coffee. So something like that. And if we provide anything else than 1, 2, 3, 4, then we will be having an else statement which says it's an invalid input. So the flow of this particular else if statement is similar to the switch statement. Having said that, we will also discuss something about switch statement as well. Basically we'll try to execute a program based on switch statement, and we will also understand the control flow of that. Don't worry about it. Now let's quickly execute this particular program first. So there you go, the program got successfully executed. Now it's asking for an input. Let's select noodles. That's how it works. We have the output noodles. So the choice is equals to 1. So the first one was true. So it executed the first code segment, and everything else got suspended because this was not necessary to be executed because the condition was true over here, and according to that only this particular statement was supposed to be executed. So that's how it works. Now let's switch into the next conditional statement, which is the switch. So you can see that we have a program on my screen which is based on switch case. So you can see that there is some similarity between this particular program and the first program we dealt with, that is based on operators. So we also have the default code segment over here. So this was what I was talking about. You can add a default code segment in that particular program, which is the operators program, and do some modifications. So this is what the suggestion I gave over there. Now basically what happens in this particular code segment is, so we have Monday as the day 1 of a week, Tuesday as the day 2 of the week, and so on. So to select one particular day of a week, you need to provide an input. So it's based on 1, 2, 3, 4 and so on to 7. And if you provide anything else than 1 to 7, you will be provided with a message which says invalid input. So now let's try to run this program and see the output. So there you go, the program got successfully executed. Now let's select the weekend day. So which would be something between 6 and 7. So 6 is Saturday and 7 is Sunday. Let's go with 7. So there you go, Sunday. Now let's try to execute this program once again and give a wrong input and see if it works or not. Let's provide 8. There you go. The program identified it as a wrong input, so it gave us a message invalid input. So that's the use of default code segment in switch case. So you can implement this in that operators program and check out how it works. Can be considered as a homework though, not a problem. Now this is how the switch case works. So with this, let's move ahead into the next concept in our Java tutorial for today. So the next segment is about the loops. So what are loops? So conditional statements are some statements which get executed based on a condition if the condition is true. If not, then that particular condition will not be executed. Loops are a little different from conditional statements. How? So basically you will be provided with one single statement and you wanted to execute that one single statement for a particular number of times. So in that condition, instead of writing the same code segment for several number of times, you can just use a loop. For example, consider that you wanted to print numbers from 1 to 10. So the brute force method, or the simple or the first method that fires to your mind is write that print statement for 10 times. That is print 1, print 2, print 3 and so on to print 10. But what if you had to print 100 numbers? Okay, doable. You can write the same print statement for 100 times. But what if you had to print 1000 numbers? Imagine 1 billion. Can you do 1 billion print statements? No, right? So in that scenario, you can use loops. So you can just write one condition. Repeat this particular print statement for 1 billion times. Then the interpreter or the compiler will take care of that. So that's the reason why we use loops in Java. So basically we have 3 loops in every programming language. That is the for loop, while loop and do while loop. So a loop statement in Java execute a set of statements until a specific condition is satisfied. So here the 1 billion example. So here you will start from the 0th count. So that will be the counter variable which counts the number of repetitions, and followed by the counter variable you will be having the condition. So you will be having the counter variable I is less than or equal to the number 1 billion. So until that you have to print this particular statement. And followed by that you will be having the increment or decrement operator. In this case you need to use the increment operator. For the first time, once the print is done, you will increment the value to 2 and the loop will be iterated once again. So this will continue. The loop will iterate itself until 1, 2, 3, 4 so on, and until it reaches 1 billionth number. So that's when the condition fails. I is greater than or equal to 1 billion. So that's when the condition fails. The condition was to be I should be less than or equal to 1 billionth. So when the number increments above 1 billion, then the condition fails. So the condition was the number should be less than or equal to billion, but the number has exceeded the billion. So that's when the loop terminates and executes the next statement after the loop. So I think this was a little clear about the loop workflow. Now to understand the loops in a much more better way, let's execute an example for each one of these types of loops. So we have for loop, while loop and do while loop. Let's execute the programs for all of these 3. So you can see that we have a program on my screen. So this particular program is based on for loop. So you can see that the code part highlighted on my editor is the for loop. So you can see int I is equals to 1. So this is the counter variable. So I is the counter variable which stores a number from where the count should begin. So sometimes you can choose 0, sometimes 1, or the number of your choice. So here I've chosen the number 1. So after the initialization part, we have the condition part. So remember the 1 billionth example we discussed before? So here we have I should be less than or equal to 10. So this particular loop segment will run until the condition, that is I value should be less than or equal to 10, is satisfied. Once it turns false, the control will exit the for loop. So that's how it's designed to work with. Now followed by the condition we have the pre-increment operator. Once the condition is checked, the control will jump to the next statement, that is the pre-increment operator, and it increments the value of 1 to 2. So this is how the loop works. Now let's try to execute this program and see the output. There you go. The program got successfully executed and the output has been printed. So basically what was this statement to be executed? It was a printf statement looped plus. Here the plus symbol works as a concatenation operator. Here too. Now in between the printf statements we have the value of I. So in the first place I was equals to 1. Once the pre-increment was taken place, the value of I will be increased to 2. So there you go, you can see the number 2 over there. Now in the second iteration we print the value looped 2 times. Similarly in the third iteration looped 3 times. So that's how it works until the last iteration, that is looped 10 times. So once the condition is checked here, the control will enter into the next part where the pre-increment takes place. So the pre-increment increments the value of 10 to 11. Now the control will come back to the initialization part. Here we have the new value for I, that is 11. Now 11 will be checked against the condition. Is 11 less than or equal to 10? No, right? So the condition here fails. Now the loop is terminated. The control will exit the loop. So this is how the for loop works. Now let us also consider another example for for loop for a better understanding. So in this particular program, we are going to print the sum of n numbers. So in that particular n numbers, we will be having even numbers and odd numbers. For example, consider that you have provided the number as 5. So the numbers in between 0 to 5 or 1 to 5 are 1, 2, 3, 4 and 5. So the 4 is even number, and apart from 4, everything else are odd numbers. So odd numbers are the numbers which are divisible by 1 or itself. So now the sum of odd numbers is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11. So that's how you print the sum of odd numbers, and the sum of even numbers, that is only 4. So that's how the loop works here. You have the condition, if else condition, and out of that if else condition you have the for loop. So this particular loop should be running until a given number that will be given by you. So that's how the program works. Now let's quickly execute this program and see the output. So there you go, the program got successfully executed and now it's asking for an input. Let's check out 5 itself. Now you can see we have another program on my screen which is basically based on the same for loop. So here we have the for loop. We will be providing an input which is num, and inside that we have another condition, that is the if else loop. So basically if loop is dedicated to find out the even numbers and else loop is dedicated to find out the odd numbers. Now the whole motto of this particular program is to find the sum of even numbers and the sum of odd numbers between 0 to the input number which you provide. For example, consider if we provide the number 5 as the input, then in between 0 to 5 we have odd numbers and even numbers. So the even numbers are 2 and 4 and the odd numbers are 1, 3 and 5. So basically what happens here is we are going to add up the numbers. So the sum of even numbers, that is 2 and 4 is 6, and sum of odd numbers, that is 5 plus 3 is 8, 8 plus 1 is 9. So that's how it should work. Now let's quickly try to execute this program and see the output. So you can see the program got successfully executed and now it's asking for an input. Now let's enter 5 itself and see the output. So there you go. The sum of even numbers up to 5 is 6 and the sum of odd numbers up to 5 is 9. So this is how the program works. Now apart from for loop, we also have another way to declare the same for loop. So that particular type of for loop is called as the enhanced for loop, or in some cases it's also called as advanced for loop. Let's see how the for loop is declared in a different way. So instead of using the typical for loop which has the initialization state, then the condition, then the pre-increment or post-increment or decrement kind of operations, we simply have declared the for, and inside that we have int arr, which is the name of the variable of array type, and inside that we have the array. So our array consists of 10 numbers followed from 1 to 10, and now this particular loop will execute for 10 times or until all the values in the array are printed. So now let's try to print this. So there you go, the program got successfully executed and we have all our values from 1 to 10 which were the input or the saved part of the array. Now with this, let's continue with the next kind of loop, that happens to be the while loop. So you can see an example based on while loop on my screen. So basically everything is same. There is no much of a difference between for loop and while loop, but the only difference is the keyword. Instead of for, we have a while over here. So we have the while condition over here which says I should be less than or equal to num divided by 2, and if this condition is true, then the control should enter into the conditional statement if num modulus I is equals to 0, flag is equals to true, and break. So basically the whole motto of this program is to find out if the given particular number is a prime number or not. Now let's quickly try to run this program and see the output. Now you can see the program got successfully executed. Let us try to provide a prime number and see if the program could identify it correctly as a prime number or not. There you go. the prime number we provided was 5 and the program successfully identified it as a prime number. So that's how the while loop works. Now let's execute another program based on while loop, but this time we will place the condition at the end of the loop. So yeah, you guessed it right, this is do while loop. The only difference between while loop and do while loop is that before the condition is checked in while loop, no statement is executed. But it's completely opposite when it comes to do while loop. First, the program or the code segment will be completely executed. After that, the condition will be checked. Surprising, right? Let's check out the practical part. Yeah, we have our program on my screen right now. So in the previous program, we had the condition somewhere over here. That's the while condition. But here we have the do statement here. So what we are going to do is we are conveying the compiler or the interpreter to execute this particular statement first without checking the while condition. So this is the only difference between while loop and do while loop. So we have run the program successfully and it got executed, and we were supposed to actually print the values of I from 1 to 20, and they have printed over here. That's how it works. Simple, right?
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Objects and classes in Java. This is a part of our Java tutorial series where we will be covering everything you need to know to master Java. Let us look at what we will cover today. First, we will talk about objects and we will implement 2 programs on IntelliJ to learn about objects. Then, we will move on to classes in Java where we will see an advanced program to learn classes more in depth. So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using IntelliJ. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name and student's age. There we go. Now we have these 3 variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need 2 classes for this program. So I'm going to create 2 classes. First I'm going to name it as bikes, and the second class I'm going to name it as cars. So let's create variables for these classes. So in cars, First I need string, name, and I need the cost of the car. So cost can be integer as well. Because I'm going to use $sign in that, so I'm going to use string because of that. So same thing I'm going to do with bikes. Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer, so I'm going to use B1 till B5. And I'm going to name them from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars and let's name it as Lamborghini. Similarly, car2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4. Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do at 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I'm gonna assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste. It will be a lot faster and easier to do. Car 2, car 3, car 4 and car 5. We don't need this. As per car 2, let's take it as 252,000 and let's make it as 3 million. As per this, let's keep it as 1,400,000 and lastly let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models, and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these values. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm going to ask which one would you like to choose. To enter the choice, I'm going to use one more variable. Let's say n. So I'm going to store n. If n is equal to 1, that means Harley Davidson. Then I'm going to show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4 and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari. Then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for Ecos. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is Shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1. And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm going to enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student. And yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars. And then I'll create one more class with the name bikes. And then one more class, automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double, and let's say fuel. And then same thing, private, double, and then year. And let's take one more, private, string, and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm gonna start with the code now. It's a very simple code. First I'm gonna create the variables or the objects of the class with private bikes, bike. So one is car and one is bike. Both are objects for the classes. So I'm going to use these objects. Bikes, bike is equal to new bike. This is so that my object can function really well. And now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed. And the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm gonna do with cars. Now how does a car start? With a key. So I'm gonna make a function public key, and inside it I'm gonna print the same message, car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message, car has been started with key rotation. Let's write that as well. So in the main program I'm gonna use objects to use those functions, and let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions. So if I execute it, these are the error messages that I'll get. Cannot find the symbol method kick or method key.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is, the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is, an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. I have named my class as Simplilearn as shown here. Followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then, the return type of the method. As of now, I have used void. Then, later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So, this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So, interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java Project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select New, and inside New you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right-click on the package and select New, and inside that, let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the employee class and gets executed to generate employee details. Now, let us try to execute this program and see the output. To execute the program, just right-click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here, the class student is the abstract class and three different student classes, namely Raju, Pranita and Punit, will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method, which is interest. So we have the classes Andhra Bank, Bank of Baroda, IDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks has been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are: the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are: abstraction is expensive, as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is object relational impedance mismatch in the case of RDBMS, and the last disadvantage is object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are: first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next, and I'm gonna name it as encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class, and I'm gonna name it as employee. So in this program we are going to use a classic example of employee using employee name, ID and salary. So in this class, let me create variables. First string name, then integer ID, and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.setID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First I'm gonna set everything. And lastly e.setSalary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this I'm gonna go to a print statement and then name and not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case that's Simplilearn. And next will be ID. and e dot get id, and lastly salary, e dot get salary. So this is a simple program that is used to define encapsulation. If we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables, so that it's secure and no one can access the variables directly. So now let's run the program. And there we go, we have our result. We have executed the program successfully, and as you can see, name Simplilearn, ID 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse. So with this, let's move on to our next program to understand it better and how we can manipulate these variables or methods using program. So again, let's create a new project. And this time I'm gonna name it as encapsulation 2 because it's the second program for encapsulation. And here we have our main program. Now this time I'm gonna use an example of cars. So let me just create a new class and I'm gonna name it as cars. So in this again I'm gonna create 3 variables that are private. So first I'm gonna get string name, then private string price, that means price of the car, and third one top speed of the car. So we can create the program that we did before as it is, but I'm gonna explain you more in depth how we can manipulate these variables or classes. So I'm gonna create a constructor for the class cars, and inside I'm gonna give it as arguments as string name, then string price and string top speed. And I'm gonna give it as this dot name is equal to name. This is so that the class can identify that we are going to give arguments related to that, and the class can return the values of it. So similarly I'm gonna give it as this dot price is equal to price, and lastly this top speed is equal to top speed. So with this we have completed our constructor for it. Now let's have getters and setters for the same thing for these 3 variables. So generate getter and setter, select all and OK. This is a great feature that we have in Java, getters and setters. Otherwise we'll have to type the whole code. So with this, let's move on to our main program. We'll write the code here. First I'll create object of the class cars, and inside this I'm gonna give arguments, or inside this I'm gonna give values that I use in constructor to assign the values without using any c.getName or c.getPrice. So my first was name, so let me just name it as BMW. The second thing was price, so I'm gonna give it as $30,000. And the third one was top speed. So top speed I'm gonna give it as 200 km/h. So we have assigned all the values to the variables and we have created object as well, all in the same line. So this is another way of creating objects, or another way of assigning values to the variables that are private. So if I try to print these, they can be easily printed. So in the starting name and c dot, so this time I'm gonna give get name, so it automatically gets the value that I assigned to the variables through getters and setters. After that price c dot price get price, and in the end top speed c dot get top speed. So if I print this, let's execute it. And there we go. We have name BMW, price, and even the top speed. Now if I give spaces between them, it will look neatly. So let me execute it once more. And here you go. Name BMW, price $30,000 and top speed 200 km/h. So this is one of our ways how we can declare variables or assign values to the variables without using any getters or setters. So in this method we used only getters to print the value that we have for variables. Now how can we manipulate the variables if we want to change value of them? Now for this again I can do set top speed or set price. Let the name be as it is. So c.set price. So price I'm gonna set it as $50,000 and c.set top speed. Let me increase it to 250 km/h. So before printing that, so that we can differentiate which one is new and which one is old, I'm gonna print one more line, stats after updation. So now if I print these values, I'm just gonna copy paste it. So now if I print it, let's execute it. And here you go. First we have name, price and top speed, then stats after updations. That means after we set the value gets overwritten on the variables, and now we have a new price and top speed and all the details. So this is how you can manipulate variables or values inside the variables.
What is inheritance? There are two other key terms which are not going to be in this agenda, but you should also, when you get to them, make sure you bundle them together as you're understanding these structures. And that's the abstract class and the polymorphism. So what is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods defined in the previous parent class. So when we look at what is inheritance, we can take an example of, say, food. We have veggies, noodles, fruits, where food is the parent, and your veggies, your noodles, and fruits are all subclasses of that. They're all kind of children of food. Why do we need inheritance? We implement inheritance for a multiple of reasons, like creating a possibility to add or remove features, to reduce the code length as we reuse the code, more comfortable to develop and maintain the project. And so if we start looking at, let's say we have a cell phone. We make calls, we have our SMS texting, our communication. On our phone we have our media. We also had a browser on there, because now we have a smartphone. And we look at that, we have our phone set up, and then we have our full smartphone, media, call, SMS, and browser. And we start to kind of link these. Instead of making them separate, we can have the call and the text, and then we can have them inherit. We can actually create a media that inherits their qualities. So now you can text your media. Now you can use the browser as part of your call scenario. And I would even add one more example in here, and that is that all programming languages that are object-based are built on inheritance. Java, Python, C++. So this concept of building an object, and then that object then is inherited by everything underneath of it, is important to understand, even in these even as we're looking at more specific cases. So we'll take a look at the components of inheritance. And the most important two components in inheritance, the two major components that are mentioned, are parent class, or the superclass, and the child class, or the subclass. And to see this, let's go ahead and jump into Eclipse and take a look at what the actual code looks like. So the first thing I want to do is go ahead and add in a new package. And we're going to go ahead and call this package inheritance, because that's what we're working with. Oops. Give me a default Java tutorial in there. Inheritance, finish. And I started off with the Java tutorial as just went in and created a new project and made sure it was Java based. So we have our package inheritance right here. We're going to go ahead and add in a new class. And we'll go ahead and call this class machine. Now, one of the standards when you're creating classes is to capitalize the first letter. So always remember to do that. In some places, people like to have the whole word capitalized. It really depends on who you're working with. But it is kind of, if it starts with a capital letter, it's probably a class. And so once we have our inheritance, we have our public class machine. Let's go ahead and give it a little bit underneath there to do something. And we'll start with protected string brand. And so whatever machine we're working with, these particular machines are going to be, we'll call them, it'll be a Samsung. Free, they get some free marketing right there for Samsung. So Samsung machines. And then we want it to do something, so let's go ahead and put a procedure in there. And we'll make it public, void, because it's not going to return anything. And we'll call this wash. I guess they're all wash machines. There we go. There's our brackets. A little trouble finding the bracket on there. And let's just have it, during this, we'll just have it do a quick print line. And we'll say initiating cycle. There. And then, of course, our semicolon on the end. All right, so now we have a public class machine. And we're going to get into where we start working with the actual inheritance. You can create an object with this machine. We haven't done anything special to it. It's like any other class you might create in the Java language. And we've added in public void wash, a procedure with no return. That's what the void means. And it's going to print out. And so let's go ahead and create another class in here. New class. And this one's going to be washing machine. Washing machine. And we'll go ahead and hit finish on here. And we come into our washing machine. It's opened up a nice new tab for us. And we might have a private string model name. And we'll change this to model type. Model type equals, so the type of machine is a top load washing machine. So we have a Samsung as the main type of machines we're looking at, and we have top loader or top loading washing machine. And then we're going to add up here extends machine. And so this is the key code we're going to look for, because we want this to have the properties of the machine. So this comes in and says whatever's in machine, we now also have in our washing machine. And then, of course, if we're going to do all this, we need to actually be able to run it. And if we're going to do that, we want to go ahead and add in the public static void main, reserved keywords there. And this is just your standard main startup. You have your string of arguments. There we go. And of course our bracket. And then in here, we're going to take and create a washing machine object. And so here's our wash machine. It's of course the type washing machine. And it's going to equal a new washing machine. So we're initiating a new object in here. There we go. And then we want it to do something. And if we're going to have it do something, we want it to go ahead. Let's see what happens when we have wash. Remember our keyword up there was washing machine dot wash. And where did that come from? Well, if we go back into machine, here it is, public void wash. There's the procedure, and it's coming into the washing machine, and this is inherited. That way we don't have to retype that every time we have a washing machine. This could be washing machine. Maybe the next one is, I don't know, different kind of washing machines. I'm not an expert on washing machines. But we have it do a wash, and then specific to the washing machine in here, we also had the type. And so we can come back up here, or brand. So we can come up down here, we can go system dot print line wash machine dot brand plus, put a little dash in there, plus, and then we're going to go ahead and we have our wash machine dot model type. That model type we put in there. So the brand, where does the brand come from? The brand's coming from our machine. We have our protected string, which is going to be Samsung. And then we have our washing machine, which has the model type, which is a top load machine. And if we go ahead and run this, after, of course, we make sure we have that semicolon in on the end there. We come up there, we'll see initiating cycle. Initiating cycle is printed out from machine, and then the Samsung top load washing machine is the second printout line here. And so when we have our wash printout here also, the wash machine wash is initiating cycle, and then we have, that's where that printout comes from. We can go back up here to machine. You can see right here initiating cycle. And then we flip back over to the washing machine, and we print out washmachine.brand, which is the machine class, and then washmachine.modelType, which is underneath the washing machine. So let's go over all that. Let's take a look and see what we're talking about here. So we saw in the code the extends keyword. The term extends is a predefined keyword in Java that allows you to create a new child class by deriving the variables and methods from the parent class to reduce code length and improve the performance. And we see that right up here in our public class washing machine extends machine. So the next key thing to talk about is access modifiers. And I kind of breezed over them when I put together the code, but we'll dig in there a little deeper. When we talk about access modifiers, there's 4 different words you really need to know, and that's default, public, protected, and private. And I'm going to tell you right now, default equals public. So what is default? Default access modifier is set implicitly whenever you declare a class without a specific access modifier. By default, the access of a class or method, when declared without a specific access modifier, becomes available to any other method or class within the same package. And in Java, the default is public. So public, a certain class can be declared as public by using the keyword public. Any class or method, when declared as public, becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. And then we have protected. A certain class is declared protected by using the keyword protected. This provides access to the methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. And then private. A certain class is declared protected by using the keyword private. This provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the method and members. So we'll take a little, we're actually going to do a different example in here, but I do like this underneath the washing machine. You can see right here we have put in private, a private string. What this means is that only washing machine can access that private string. Where if you have protected, the children can access it. So a protected screen, if you're underneath a machine up here, we have protected, so that when I create the washing machine and extend machine, I can still access it. But if I create a subclass of washing machine and I mark it as private, that subclass is not going to be able to access it. And so it has to do with what layers of accessing. Think of this as a big team project. You create something, do you really want that to cascade down to the next class? Or who do you want to have access to that? Let's go a little deeper to really bring this home, because it's really important to understand this terminology. Let's go ahead and start a new class here, and we're just going to call this particular class summation. And go ahead and create that, finish. And so our summation class, it's going to be pretty simple in here. We'll go ahead and do public. So anybody can access it. Just remember, here's our public on there. And then we'll just do a integer, because that's what it's going to return as an integer. We're going to call it add. And we're going to put integer x comma integer y. And then we'll just return x plus y. So real simple. We're just adding two numbers. Here's our two inputs. They both have to be integers. And we're going to return an integer, and it'll be the summation of the two. So real simple class right there. And if we're going to have a summation, then let's go ahead and create a new class, and we'll call this one child. And in our new child class, we're going to go ahead and keep this simple, and we're just going to have our public static main. We're going to have our summation a equals new summation, and then system out print line a dot add 100 plus 200. Pretty straightforward. Everything's public in here. Oops, okay. There's our running, and we see that the answer is 300. So this is public. If you remember correctly, we're talking about public. And so when we use the public keyword, any class or method when declared as public becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. So here we go. That's our public setup. It's just open to everybody. Well, everybody that's under the package inheritance. So it's whoever's using that package can now use this particular child. And let's go ahead and add a new class in. And this time we're going to do a parent class. I'll just put that right in there. And we come in with our parent class. You can see right here the parent class itself is public. But what we want to do underneath the parent class is we want to create a protected void, because we're not returning anything, and print. So we're going to do the print there. And this protected print, let's go and put our brackets in there. And we'll do just a simple print line hello world. And once we have the print hello world, we want to go ahead and add a child class to this. And let's see, we had the child class when I took it out a second ago. So we'll go ahead and put that back in. Here's our child class. And for this child class, we want it to go ahead and extend the parent. So inheritance, there's our extend on there. Oops, let me retype that. All right, extends parent. So now the child class is part of the parent class. And we'll go ahead and put our main in there so that it will run it and execute it. And we'll create our child x equals new child class. So we'll go ahead and assign our variable x and initiate it. And then we'll do just the print and see what happens here. So here's our print statement. And we'll go ahead and run this and compile our child on there. And when it comes in there, you see it says print hello world. And so the parent has marked this as protected. So it's protected from objects that are not inheriting it, but the child can still access that information and print it on there. So here's protected. This provides access to methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. In a lot of programming, that's usually where you end up, is doing a lot of stuff that is underneath your parent that is protected. You either make them public or protected. A lot of people are sloppy and just make them public, but most of the stuff you want to make sure it's protected. And then we finally have our private, and I'm going to go back here to our child, and we're going to run this. And it's going to come up and say proceed with launch, errors in setup, and then it's going to give us an exception thread main. Compilation error, the method print from the type parent is not visible. And that's because unless you actually initiate the parent, you're not going to see this code because it's private. It's only private to the public, to the parent class. So even if I extend it in child, it will not be available. And that again protects it. That means it's something that you don't want to inherit and cascade down, because maybe it is a piece of code that is going to be changed, and so you don't want all the children to crash every time you make a change to it. So with private, this provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the methods and members. So very important. We have private, and we have protected, and we have public. The more access you want other pieces of the software code to have and other programmers to have, the more public you want to make it. and of course the default is public. Now, one of the common workarounds for this, because you're going to have protected data, but you still want it to be used by the subclasses, is to create what they call like a get or a, and we'll do it up here. We'll go ahead and do a private integer x equals 5. And then instead of, on your inheritance, instead of having it call it from the child, we might have a get thing, or a get thing. We might have a public, it's going to return an integer, and we might have it say get x. And this simply just return x. And what this means is that when we have something simple like this where it just does a return x, I can go back into my child here, and instead of print x, we'll do x dot get x. And we'll go ahead and print this out, or yeah, something simple with that. We'll go ahead and do a system print line on this. And when we run this, you'll see it come up, it's going to recompile, and we get our 5. What's happening here is now I've created underneath the parent private information. You don't know what's going on with it, it's protected. You might have a procedure that's protected. In this case we had the print procedure, and then we access it from the public. And this could have easily have been, instead of, maybe we'll just call it public void public print. Kind of a goofy way of doing the code. There we go. And then it could go in here and access our print. And so we can actually still access this print variable up here by wrapping it in kind of a get or a public function. This allows us to protect whatever code is going on in the parent class, so it can't be messed up, it can't be accessed indirectly, it has to go through the right processes. And so when we get to the child on here, the child can then still has the public processes, but all the other information is protected and is private. It's really important to remember that private right there. This brings us to super keyword. And when we talk about the super keyword eliminates the confusion between parent class method and subclass method. Super keyword is implemented to access a method or constructor that is defined in the parent class. So back in Eclipse, we'll go under parent, and we'll take this, we're going to take the private out of there, so now we have an integer 5. And we'll go ahead and just remove the print because we're not going to do that in the parent. Oops, and the public. There we go. And so let's create a parent that just has one piece of information. It has an integer x equals 5. And then we're going to go to the child, and let's go ahead and add in here integer x equals 10. And these are, by default, they're public. We haven't set anything on here telling it what it is. And so what I'd like to do is we'd like to go ahead and create a, oops, one more thing, there we go. Create a procedure here, and we'll just call this void capital print. And it's just going to be a system out print line. And this is what I want you to notice is we're going to print out x and super x. So we have the child class x and we have the parent class super x. And if we come down here and we do x dot print, don't forget my semicolon, add a couple spaces in here to make it look nicer when we print it. And we'll go ahead and run this. And you can see that the child class prints 10 and the parent class is 5. And so this way you can actually store different information depending on what it is you're working on and what you're doing. And that's where this super comes in. You can see right here where the super underneath the class and the print module. Now you can't just put it in down here under print. And we can explore what that looks like. If I just take this and I go ahead and highlight it. And let's say I wanted to just, instead of doing xprint, It's going to come up right here. And right off the bat, you see the super.x. I could do x.super.x, and it's still going to give me an error right here. It has to be underneath a procedure in the actual class and not under the main. This brings us to types of inheritance. And there's 4 main types. We have single inheritance, which we've already pretty much looked at, but we'll go back over. We have multi-level inheritance. We have hierarchical inheritance and hybrid inheritance. Let's go ahead and just start with the single inheritance. Single inheritance consists of one parent class and one child class. Here, child class inherits parent class methods and data members. And let's go ahead and create a new class up here, just to change it up and keep it interesting. New class. And we'll call this one student. And under the student, we'll have a simple setup. We'll just do an enrolled, and it'll say enrolled in Simplilearn. There we go. So there's our class student. And then we'll create another class. We'll do it as because we have our student or base student. And then we'll call this one new class. And we'll call this one computers. There we go. So he's enrolled, finish. And for computers, let's go ahead and put in a print line here. And we'll put down studying computers. And we want to go ahead and do the extends student. So it's a student studying computers, subclass computers. And this would all look familiar because we've been doing this for, a lot of the other setups. This is your basic inheritance. And we'll change that from enrolled to studies. And then let's go ahead and put a main in here so we can actually run it. And we have our P enrolled, which comes from our parent class, and our P studies, which comes from the child or the one that inheritance it, the extends for student. And let's go ahead and run that. There we go, run. And you can say enrolled in Simplilearn studying computers. And then we can go on to the next setup. And this is where we look at multi-level inheritance. It is also a parent-child inheritance relation, but the difference is the child class is inherited by another child class. This is the basic structure of most programming languages right here. You have an object, you have all the different things under the object, and it gets all the way down to whether it's an array you're working with, whether even a class is a subchild that goes all the way up to the object. And we can simply do that in our code in Eclipse. And we'll just go ahead and add a new class in there. We'll call this one Java. There we go. Oops, Java. And under Java, we want to go ahead and create some of the similar stuff. And then I want to go back to my student. I took out the main and student just because I don't want it to run the main in there. And in here, we're going to have system out. We're going to have, instead of studying computers, focus on Java, which is what we're doing right now. And maybe we'll call this classroom. And then we can come down here and we have our P equals new computers. Well, instead of new computers, we want our Java. And it's going to be a Java object. And we need to put our extends in up here. Extends, in this case we came from computers. So there's our initial thing. And then we have our last print in here. And of course, if we run this now, we'll see that it should, if I did everything correctly, come up and say, enrolled in Simplilearn, studying computers, focus on Java. And we have the enrolled, which is the parent to computers. And then we have under computers, we have student, then computers, and then Java. And so each one of these classes just cascades all the way down. And this is your multi-level from your class A to class B to class C. And if you can have multi-level inheritance, we can also have a hierarchical inheritance where your parent-child relationship, the only difference is here multiple child classes inherit from one parent class. And that is pretty, we'll do another class here. If you remember correctly, we had student, computers. Maybe from student we'll have, instead of computers, we'll have project management. Project management. So you're studying your IDLE and all your other classes in there for Cascade and for doing agile programming. And in here we can do that. And it's just the same as we did before. We just have a second child coming in from here. And so this would go ahead and extends student. And of course, whatever subcategory you have one in here for running this. And so for here, we'd have like our void studies. In this case, instead of studying computers, we're studying project management. Project management, one of the other wonderful classes that is taught from the Simplilearn team. And we'll go and run that, and you can see right here we have computers. Oops, of course, instead of computers, I meant to do project management. There we go. And we have to also initiate it as a new. And then when we run here, we can see this. We're enrolled in Simplilearn, and we're studying project management. And then finally, there is the hybrid. The name itself explains it to us. The hybrid inheritance can be a combination of any of the 3 types of inheritance supported in Java. And so maybe we already saw that because we have our A and our B. If we flip back on over to our Eclipse, we have our student. Our student now has a computers, project management. So there's our hierarchical, and then they're mixed because we also have the Java, which is an extension of the computer. And so we have multiple layers there. So one of the issues that comes up with inheritance in classes is what they call the diamond problem. And in the diamond problem, the Java programming language does not support multiple inheritance, as it ends up with serious ambiguity. And that is where we have D, which inherits from both B and C, which might both inherit from A. This is the diamond factor because as you start tracking your supers going up, which one are you actually looking at, B or C or A? And that's why they call this the diamond problem. It comes up more than you would think. You get very complicated structures and you realize, oh, I need to have both sets of instructions come down to whatever I'm working on. And you can see where that can become a problem. Let us take a look at is a relation and has a relation. Now these, they're vocabulary, but they're more of a concept, understanding how things fit together. And so when we talk about is a relation, when a class inherits methods and members from a different class, then the relationship is said to be is a relation. Examples, orange is a fruit. And let's just jump back on over here and we'll make a new class. And we'll call this class customer. So we're going to have our customers. Oops. There we go, if I can remember how to type. So we have a class customer, and I've gone ahead and our team in the back went ahead and prepped this for us. Let's just take a quick look though. We got public string name, so it's accessed publicly. If you leave this out, it'll automatically be public because that's the default. And then we have our customer and the string, which is a name, and a string is a city. And then when you do a customer and you send it the name and the city, it will do this name equals name and this city equals city. We could have easily done this private. We have a call into it to create it. So it wouldn't really matter too much whether we did it private or public. I would actually be more likely to do it private. And for this example, we'll go ahead and create another class, and we'll call this store. We'll have our store class. So we have customers and we have a store. And then we'll go ahead and set up in here. And this time we did do a private. We're going to create a list of customers, and then the store list coming down, and then this customers, and public list customers. A quick look at this is we did make this one private, which is nice because now it can't be accessed externally except from store. And then store has the public list customers. So we can send it a list of customers, and then it go ahead and returns the customers from that list. And then when we add it to the store, it sets the customers in the store. This.customers equals customers. One of the reasons we have the error lines in here is I haven't compiled it, so it doesn't see the customers are part of our package. And we'll get to that in just a moment here. And then let's go ahead and create another class. We'll call this isARelation, since that's what we're working on. And here's our isARelation setup. And we're just going to put this as the main, so you have your main in there. And then we went ahead and prepared a series of customers. And we'll just call it customer C1 equals a new customer, customer C2 equals a new customer. And we're just creating a list here. That's all we're doing. And if we're going to have a list, then we need to go ahead and create a list of customers. And we'll just do that with a simple list setup. And then we got to add those customers into the list. So let's go ahead and do that. So breaking this down, we have customer 1, which is Raju, Bangalore, Shiva, Hyderabad, Sachin, Mumbai, and so on. And then we just created a list of customers, a new array of lists, and then we add in each of those customers. So now we have a nice list of all our different customers in here. And then we want to go ahead and create our store. And we'll put in store, and it'll be a Fruit Smoothies franchise. I put down Fruit Smoothies Franch. Maybe that's not a good abbreviation because you might think it's a French instead of franchise. But it'll be a new store. And then we have our new store, which is, in this case, we're going to put in that new store customers. And if you remember, we went back here into store. Let me just flip back on over there. It's going to take that list of customers and put that into this customer. So now the private list is going to equal that list of customers. And then, of course, we can come in here and we do public list. It's going to return that list of customers. So we have public assets here, and this store, you can add public at the beginning. We'll go ahead and do that just to make it clear. Is it public? Is what's going to run on there. And let's go back into our isARelation. And flip back to store. I'm going to go ahead and just change this to customer list. So here's our list, customer list, and it's going to return the customers from this selection, from our private variable. So we come into here, we can come down here and we'll go ahead and put that in there. We'll do a loop on this. We'll have a list customer, and we're going to create a list of our customers from our Fruit Smoothies franchise, and we'll get the customer list from there. And then for a customer in the for customer CST in customer, we're going to go ahead and just print that name out there. Now at this point, if you have an error showing up here under list and also underneath array list, depending on how you did your install, you might have to go ahead and import those, your array list, from your Java utility. Not a big deal. And then once we go ahead and we have this all set up, you'll see here the compiler goes through, and then we have the name of the customer, city, and then it just lists the customers going down here. So when we talk about our relationship of our Fruit Smoothies franchise and customers, the customers, they are a relationship directly to the French Smoothies franchise. Now, the second idea is it has a relation. And let's go ahead and take a look at that and see how that differs. And we'll go ahead and create a, let's see. We had customers, so let's do, and we'll call this one, we're doing with smoothies, so we'll have flavors, or favorite. We'll do favorite flavors. Favorite flavors for a class, very strange class. And let's see, in favorite flavors, we'll go ahead and give it a couple things to look at. We'll have a private string and a name, and then we'll have a public string get flavor. There we go, and that's just going to return return. We'll just have that return the name of the flavor. There we go. And then we want to go ahead and create one more class, and this class we'll call has a relation. And I'm hoping you're guessing where we're going with this. Let's go ahead and put some code in here to make it work. And let's go back to our favorite flavors and put in a constructor so that we can load the flavors, and then return this name so we can return the flavors. We'll go back into has a relation. And let's just create a customer. We'll call it cust. Our new customer is Toby Marshall from Mumbai. And our favorite flavors are strawberry, banana, and peanut butter. I don't know, it's a strange concoction. And then when we run a print line, we're going to print the customer name from customers and the flavors get flavor. And so when we're looking at this, what I want you to be aware of is that neither the flavors nor the customer are in the same class. It's not an actual relationship, but they have a relationship, because we have Toby who happens to like strawberry and peanut butter. And if you remember, just a quick note, we were looking at the diamond problem. You can create a class that then has these two subclasses in. And that's how you go around the diamond problem, is you don't inherit, but you create classes inside the class you're working with. What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom, it can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor, and we're going to do some animal sounds with cows, cats, and dogs. Just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package, and we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here. And we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just, good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in a, let's start with a cow. Yeah, why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class. But a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog. Why not? So here comes in our dog. And of course we want the dog to actually say something. And we'll have the dog go bow wow. And then we'll go back to our animal main and we have to create a dog. And we'll say cow. Simply dog, dog. Uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound. So we'll go down here and go dog dot sound. And when we run this, as you expect, it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and it went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, in Java, the process of method overloading is achieved when a class has two or more methods with same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this one's going to print out the dog says growl growl. Now if we go back to our animal main, and here's our dog, same sound, but now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl growl. So the dog says bow wow, and then the angry dog says growl growl. So there is another thing called operator overloading. Operator overloading is not supported in Java. Authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here, the overriding method gets resolved in execution. So far, we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, this is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super dot sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains, and it's printing out or doing whatever it does here. At this point, we usually have it return something, so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs to handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as the method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see where as you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then actually it's very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. Just depends. The more you use it, the easier it is.
What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic, where we face the Java collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java collections API. To understand these in a much better way, we shall now go through the Java collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22 and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22 and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53 and 65, and the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in three names, which are David, John and Stacy, into our list, and also we have a fourth addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the fourth element, which is the duplicate of the third, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the fourth element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or pull. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits: apple, mango, grapes and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the dequeue interface. So what exactly is a dequeue interface? So a linear collection that supports element insertion and removal at both the ends is called as a dequeue interface. The name dequeue is short for double-ended queue, and is usually pronounced as DEQ. Most DQ implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted DQs as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the DQ. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for DQ interface. So here we are going to add in some elements into our DQ and then also try to remove the first element and print the updated DQ. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the DQ were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that, the updated DQ is having two elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains three general-purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add three elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names have been arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this we finish the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the HashSet class. So the Java HashSet is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for HashSet classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the HashSet classes work. Moving further, we will deal with the next type of class, which is the TreeSet class. So a TreeSet class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the ArrayList class. So ArrayList in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3, and 4 in the matrix form, and we are going to use two for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3, and 4, and the elements are printed in the matrix form. At the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked list also come under Java collection classes. There are three types of linked list, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into two parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation, which stores the second element. Similarly, the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3, and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3, and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have two address locations. So the first address location of the head stores null, and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have two addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4, and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3, and 4, and 5. So this is how the W linked list work, and now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6, and 7, and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for hash map class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed, and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time, depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet, and Reynolds, along with their respective IDs. So now with this, we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2, and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48, and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in disorder. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4, and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array. using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is, whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally increased speed in programming. So these were the major benefits of Java collections. What is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arises is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic, where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime. Whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors, for example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see on our screen, we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string ABC has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources.
What is JDBC? JDBC is a tool or an application programming interface that establishes a connection between standard database and Java application that intends to use that database. Need for JDBC? Establishing database connectivity to execute MySQL or SQL queries and DDL/DML commands. View and modify data records. And one of the most important things to look at when we're talking about a JDBC, and probably the most confusing part where the devil's in the details, is data types in a JDBC. So when we start looking at the data types and you're setting up your data, you have your SQL, which is your var character, and your Java equivalent, java.language.string. And you have your bit in SQL. In Java, it's Boolean. In SQL, it's numeric, java.math.bigdecimal. Integer, int, real, float, float, float. So there's no real difference in Java between a real number and a float number. Your double is double. Your binary is a byte. Data, Java SQL date. So your date in java.sql date. And there's also your SQL timestamp, java.sql timestamp. Array, java.sql array. Reference, java sql.reference. Structure, java.sql structure. Character, java.language.string. Big integer, long in Java. Variable binary is a byte. A clob, and that's character large object. And then the equivalent is java.sql.clob. And then you have your blob in SQL, which is a collection of binary data stored as a single entity. And the equivalent in Java is going to be your java sql.blob. Now, if you're doing a lot of programming, I would suggest having a cheat sheet there. And then once you're up and running, you'll start to remember most of these just because out of use. With the JDBC architecture, we're looking at the application, then it goes into the JDBC API. So you have your application you're writing, your Java Database Connector API, then that has a manager underneath of it, and then you have your Java Database Connection drivers. And the drivers are the ones that are transferring that, whether it's an SQL server, MySQL server, the Oracle database, or different sources that use a JDBC connection. JDBC environment setup. So when we talk about the environment setup, we have Java and your environmental setup underneath of that. In setting up a Java environment, you have to download the latest JDK, set Java to home, and set your Java path. So if you're just using Eclipse for the first time or whatever IDE you're using to program, you want to make sure you have that all set up and you have the current JDK in there, the Java development package. And then with MySQL, setting up MySQL environment, download the latest MySQL workbench, extract the file, run the setup file. And that'll get you set up with your own MySQL on your computer. And MySQL registers with your operating system. So it's kind of like a global variable when you start accessing it. And it's designed that way because normally when you're using an SQL or MySQL database, it's installed on a server. So it makes sense that you want it registered with the operating system so it's accessed globally. Steps to connect your JDBC. Step 1, import your packages. This procedure is followed to make sure that the relevant packages are readily available for the API. Step 2, load and register your driver. The imported drivers needed to be loaded and registered for establishing a connection between application and database. And if you remember, in this case, we're doing the MySQL, so we make sure our MySQL driver is installed. And step 3, connecting database. After the first two steps, the next stage is to connect the database. This can be done by a GET connection. Step 4, writing a query. So now we're actually starting to get into your scripting. Here we write in the SQL command or query that we need to execute. If you're not familiar with SQL, it's good to have an SQL cheat sheet set up. Once you start understanding how it's put together, you'll find that it goes really quick and it's pretty fast to learn, but it is its own query language, and you do need to learn a number of the main settings and poll language so you know what you're doing. Step 5, executing query. Now the query from the API is executed using execute query, and we'll actually load that up just as a string variable. When we look at that, you'll see how that fits together. Step 6, processing result. After step 5, the system basically does two things. It processes an output and retrieves the values from your query. And then step 7, closing statement. The result set and statement needs to be closed explicitly. And you'll find there's 2 closing statements. There is your result set, which is still pulling from the database. And then step 8, which is we need to actually closing connection. So the last stage is to disconnect ourselves or the API from the database. So we no longer have that open connection using resources. So we're going to jump into our Java database connection example. And we're going to do that with what we call the university database. Let's start with a basic overview of MySQL. And you can go to dev.mysql.com. And you'll see here we can look up more information. They have the download of the newest version. This is a full SQL database package, and some of these you can actually go in there, and if you're doing database management, they can spread across up to, usually don't want to go more than 5 servers, but it is designed to go up to 5 servers kind of set up with terabytes of data in there. For a developer on the programming side, we usually want to install something like MySQL locally. So on my setup, it has no network connections. It doesn't auto start on the boot up of the computer, and I have it locked down. That way, if I use some kind of simple password or something like that for one of my demos, it doesn't go anywhere. No one can access it. Now, another option to MySQL is also the SQLite. And you can go to the sqlite.org, read more about it, and download it. It has a couple limitations that you're not going to see in your full-scale MySQL or Oracle or SQL, but most of it will transfer over. And so for a small project, you can actually use it as the backend for storing your data. You can also integrate it or upgrade it into MySQL because most of the SQL commands are the same. And when you go into the MySQL, which is a significant download versus SQLite, you can certainly go down to downloads, and then there's also the connectors. So devmysql.com/download/connector/j. And I bring this up because it depends on how you've set up Eclipse for your interface and your IDE, and it depends on what you need and how exactly on your setup as far as the connectors. We'll look at that a little bit more closer. In the MySQL, it is an Oracle based, so you'll have to set up an account if you don't have one. You have to log in. It's all free. As long as you're not doing like the enterprise with all the support and help on it, you don't have to pay for it. It's an open source. Now, once you've installed MySQL, and if you do SQLite, you're not going to have these interfaces. It'll all be done from Java code. But once you've installed MySQL, it's going to add in a terminal window and then also the workbench, which is just a nice GUI interface for MySQL Server. And we're not going to do anything with the workbench. You can play with it certainly, because a lot of times you don't have the workbench installed on your computer, especially if the MySQL is set up on a different server and you're remote accessing it. Especially if you're in the classroom or something like that, they probably have sent you your login information so you can get into the shell. Quick note though is if you do your own MySQL, just note that I kept this as a local host. You can actually see it down here, root localhost, no outward connections. And that's just to protect my computer. Once you start opening those, you have to be aware of your passwords. And since I'm doing demos, I want to keep my passwords really simple, so that's not the focus of the programming. I had to log out and relog back in. So once you've gone in there, you should have this. A lot of times your interface might be web-based if it's a remote MySQL connection you're working with, and it'll prompt you for your username and password. In this case, mine is on my computer. It automatically has me log in as admin, so I have full admin rights. And then we always like to start by, at least I do, is show databases. And these are the current databases on here. They have some different information on them that is part of the basic setup, and some examples like Sakilla and World are both example databases that automatically load with MySQL. For this example, we're going to create a database, and it's going to be university. We'll do capital there, university. Don't forget our semicolon. And time, you can see how long it took, 0.69 seconds. And of course, if we go show databases, you'll see now that there is a university in there. And we want to go ahead and use university. That means that whatever we do, any commands that we have in here for tables or whatever are now going to be going into the university database. So now our database is changed. And let's go ahead and zoom in. Let's see, here we go. Set. Okay. A little bit more so we get the nice big print so you can see what I'm doing a little bit better. There we go. All right, so we're going to go ahead and create our table. And this has all been prepared, so I don't have to go through and redo it all the time. You'll see here we're going to do create a table engineering student, and then we have student ID as an integer, not null, department variable character 25 long, first name, last name, pass out year, university rank, primary key. In creating this, note a couple things. First, we created a table, engineering students, and we've gone ahead and created the fields as part of the create setup here. And the things I want you to note is that we have our integer. So our student ID is an integer, our department is a variable character, and it's 25 long. And the reason I say that that is really important is when we flip back on over here, if you remember from our, there we go. If you remember from our data types, here's our variable character, and in Java language, that's a string. A string doesn't say, hey, it's only 25 long. And so you got to be a little careful when you're pushing and pulling this data, especially when you're writing the data from Java into the SQL, that you check for that length of that string. And then the integer is, of course, an integer. And of course, your other data types, you can see how they follow suit. But with variable character, be very aware of that that is designated 25 characters long. And we're going to go ahead and insert some data in here. Here we go. We'll go ahead and insert into engineering students values. And this is going to be the student ID. And it's also the primary key. So keep in mind that that is a unique value in there. And then we have CSE, Computer Science Engineering, Quran, HackerEarth, 2018, 1272. So there's our pass out year, 2018, and ranked, I guess, number 1272. I'm not sure where the, oh, that's a university ranking. There we go. And then we have some prepared data, which I just went ahead and pasted in. So we have a whole bunch of individuals in our database now. And it's the same line over and over again. Insert into engineering students, values, and then you have your list of values. And we can see that by doing a simple select. We'll do, star. So it's going to select everything, one of our hot characters. If you're not familiar with SQL, get a setup on there and look it over. And you can also download a cheat sheet from somewhere with all the different commands in there. I myself do a lot of consulting, and so I'm always jumping around from one platform to another. If you're doing that kind of work, it's more important to understand the limitations and the advantages of different systems, and then you have your cheat sheets for putting together stuff really quickly when you need it. And you can see here the data we just put in there. There's our student IDs, department, first name, last name, pass out year, and university rank. And we'll go ahead and do one query in here real quick. We already did one query. We're going to do two queries. We did select star from engineering, and then we're going to go ahead and select student ID, department, first name, last name. So you can actually choose what you select instead of doing the asterisks. Where student ID equals 10202. And when we go ahead and execute that in here, oops, there we go. You'll see that it returns the one individual with that student ID here. So let's take this back into our Eclipse because we're still doing the setup. So you have your MySQL Server setup, or you did SQLite with a little bit different setup going on there. And let's flip on over and see what's going on with Eclipse. So in Eclipse, we're going to go in new. We'll start a new project. And we'll call this JDBC. It's our JDBC project. Whoops. Select a wizard. I forgot where I was going on there. It's a Java wizard. We're looking for this project. Java project. There we go. And we're going to call this there. Now we're in the right spot. JDBC package. That way everything will be bundled in there in the same package, and finish it. Create. All right. So you can see right here we have our new JDBC package we're working with. Now at this point there's a lot going on as far as your options. If you set this up for doing database management, which I did not, and I'm going to show you the two different ways, you can go under Windows and under Preferences, and in this list you'll see database management, and then you can just go in there and set it up this way, and it'll pull in that information for your SQL connections. Now, if you did not, and you downloaded the MySQL, it does have an option to download the Java Connects, which would put it into wherever you installed that at, which is default under your C drive program files. Now, on mine, I didn't. I downloaded the connection separately. And there's two different ways. We can go under Project, and under the Build Project, give that a moment to come up. Oops. I mean Properties. There we go. The Project Properties and the Java Build path. This same window can be accessed by right-clicking on your package we're working on, and then we can go down to Properties, and you'll see the same window opens up. And we're going to go under Java Build path. We're going under Library. So these are libraries we want to include in our setup. And then I click on our module path. And at this point, you'll see Add External Jars here. Now again, if you have it already pre-set up in Eclipse, you can just add jars and it will be in the jar library. So there's different possibilities there. But I did a download, so I'm going to go Add External Jars. And I happen to keep mine on my D volume under my SQL. And you'll see my SQL connector Java, and this is MySQL 8.0. And I just go in here, oops, there we go. I just go ahead and open this up, and you'll see right here it has my connector Java. Once I set that in, it's now added those packages, and there's hundreds of actual subfiles in there, and it's all set to go, and I can apply and close this window. And now I'm ready to go ahead and start writing my script and start building a program in here. And let's go ahead and go under Source, New, and we'll go ahead and put in a new class in here, and we'll just go call it JDBC. Same as the package. We'll go ahead and finish that. And we're set up with a new class in here. And once we've got this set, the first thing we want to do is we want to go ahead and import all of our Java setup in here. So we have the Java connection, and now we want to go ahead and import it. And when we look at this, we can see we have our connection. And remember, two of these have to be closed explicitly. And that's your connection and when you create the statement. You have your driver manager. So when it goes in there, that's the piece that connects to, actually does the connection to the database, the drivers that convert everything and the code in there. So you have your connection to the database. You have the code that converts it. You have your result. So you're going to get a result off of your query. Then you have your exception. So if you have an error throws or something like that, that's where that's going. And of course the actual statement that you're going to send to the SQL server. And of course we want our Java to be able to actually run. So we'll put our main in there, public static void main. And it's going to throw the SQL exception. So you'll see right here, that's what we're working with, and there's our Java SQL exception on there. So the first thing we're going to need on our setup, let's put that in here, is going to be our connection information. We need to know the username, and we're just going to call it string uname equals, in this case I created a user, Richard_Simplilearn, and then I created a password, my password. Remember, this is a local host. So you probably don't want to have a simple password like that, but this whole database is locked down on just this computer. There's no outside network access or anything like that to get in here. And then, of course, this is a separate user, so it's not even my admin or root user. And then we go ahead and put a query right here. In this case, we'll start with our most basic query. If you remember, we already did that on our, at the very beginning, select star from engineering students. And we're going to use that query in our code to start off with. And then another really common thing when you're setting this up is that we also want to test it and see, hey, did we import our package correctly? Is it set up correctly? So you remember we came in and we imported our MySQL connector jar file. In the code, we would just want to make sure it's working correctly, and that's what this is. It says try class for name, and then it has our com.mysql.cj.jdbc driver. It's saying, hey, do we have the driver for this? That's all that's doing. And if not, then it's going to print an error so we can find out why it doesn't have that driver. And then next we want to actually start getting into our actual code. And in here we're going to do a try, because whenever you do any kind of major connection, you want to make sure that you're looking for your errors. You're not going to mess on anything. And we're going to do a catch. And so we're looking for any kind of SQL exception error. And for this demo, we'll just do, print it out. So, oops, wrong spot. It goes into the catch section. There we go. So we'll print it out over down here as far as the error on there. And it's an SQL exception, so it's still looking for the code, which we haven't put in here yet. And this is really where the magic really starts to happen, because we have our connection. And there we go. And you'll see that the connection is, that's all this is right here. Here's our connection up here. And we pop it down here. We have a connection. We'll just call it con. Do one end, so keep it uniform. There we go. And this is going to go to the driver. So in other words, right here, we're going to go ahead and need the driver manager. And that's where we imported here. And it says get connection, because that's part of the driver manager. And we have our URL. Let's see, and we of course forgot to put the URL in up above. So let's go ahead and go back there and put that in. And the URL comes out as a JDBC MySQL. That is registered with my computer. So my computer has, when it's running the MySQL, this is the local host. In this case, we call it university. That's where this comes from. And that's all part of your MySQL setup. If you're working with a remote database, you'd want to get this information from the remote, whoever set the database up, so that you have this particular line of where to call. And so when we go back down here, we have our connection. It's all set up on here. The next thing we want to do is we want to go ahead and create our statement. And this initializes it. So we have a statement called statement. But this statement's going to be based on our driver manager, which is then connected to the connection. So these are all connected to each other. And this generates the format it needs for when we actually send our inquiry. Remember, here's our query right here. So we're going to send select star from engineering students for right now. We haven't put that part in. We're just creating the class or initiating the instance so that we can do that. And then once we've initiated the instance here, oops, go down here, we need to go ahead and generate a result. And so we have our result set. Again, that comes up here from what we brought in. We're storing the data coming in, or storing the pipeline to bring it in. We're just going to call that result. And then we have, this is generated from our statement. Here's our statement. So this is all like linked together. Here's our execute query, which is part of the statement, and here's the actual query, which is coming that we put together, the select star from engineering students. And then finally, we want to actually do something with our information. So what we'll do is we'll just loop through it while, and here's our result set that we just generated. So while result dot next. And this just generates a Boolean. So it says, hey, there's still another result coming in. So we need to go ahead and get that next result. And we'll go ahead and create a And we'll take that string university data, and then we're going to loop through the different results. There we go. Integer, and then here we go, university data. And we want to tag on the end of it result.getString_I. So what's going on here? We just did a bunch of things. We are going through each row, result.next, each row of data that comes off of the database until this returns null. There's no next result coming in there. And then we come in there, we look at the result. The one we're looking at is the current one, so it goes through, I forget how many we put in there, about 20. It goes, row 20 with 0, row 1, row 2, row 3, row 4. And then on each of these rows, we have a string, and it's an array of strings, and we're going to get that string, and it returns I. So this is get string of column I. So we have row and column. And really important in today's programming to really understand rows and columns, because that's so central to most of the data processing going on. And then finally, we want to go ahead and see our results, so let's print them out. We'll put in our nice print statement, system out print line university data. So this is going to print each row as it goes through it, and then I'll reset the row again to an empty string, and then I'll add each of the columns to that row from our result, and then we'll print the next row out. And now that we have a complete code, let's go ahead and go up here, hit the run button. It's going to compile it, runs it out, and we can see down here, let me just get my double mouse so we can get a better view. Here's our different, your ID comes up, I forget what the actual setup was, but the CSE, the name, the date, the ranking, all that prints out one row at a time, and that's what we're doing here. Of course, if you're processing the data differently, you might be loading this into a user interface. This might be generating other information. You might be doing statistics with it, but you can see how it's set up in here as far as pulling the data into the Java format and then running it from there. Just so we can get a quick glimpse of where this goes, let's go back up here, and we're going to flip back and forth between a couple different screens, so let me do that. And here, if you remember, we did select star from engineering students. And there's the same thing up here that we got down here. This is our MySQL Server interface, and this is the interface we built in Java. And if you remember, we also did this particular selection, select student ID, department, first name, last name, pass out year, university rank from engineering students where student ID is. And we got the single row on here. And this is kind of interesting because I switched something in the code here where this could cause a problem. It won't on this one. Let me go ahead and paste this in here, and then we'll run and compile this one. And you see it comes out with the single user. So the danger of this particular code is that I went ahead and hard-coded in a loop for I equals 1 to 6. And so this one we pulled, it just happened to be that we selected 6 different columns in here. So you got to be a little careful when you're coding in here. What are you pulling and where is it going? You can see if I take out, let's do, we'll just remove the student ID. And we're going to run that without the student ID. We compile it, there we go. And it gives us a bunch of errors because it doesn't see we're short a column down here. So when it gets down to this code down here, under the while statement, and it goes, hey, where's number 6? Well, there's no number 6, and so we get a lot of errors on that. And you can see where our queries, let me just go back up here and paste another query in. There we go. And we'll run this one, and what we're looking at is we're going to go ahead and do the same columns, and we'll just leave this as a star to make it easy. So we're going to select all columns. From engineering students where the pass out year is 2018. Let me just do a copy of that one. And we'll run that. It recompiles. And you can see here's all the 2018 on here if you look at the dates. So they're all 2018. And that's the same as our query directly into the SQL Server. If I do the same thing on here, you'll see they're exactly the same. And just because we're having fun, let's flip this back over here and we'll do one more SQL Server. And let's do in this one, let's see, let's just take this whole thing out here. And in this one, we're going to pull in all the departments, but I want the minimal university ranking as the highest from engineering students. That way we can get an order of the rankings on here. And we'll go ahead and run this. And there we go. There's our minimal one. So this one hit the lowest ranking on there, or closest to number 1. And we can do that in here and get the same result. There's Karen. Karen is awesome. Ranking number 96. And you see all these other people that are ranked way below Karen. So this guy must be super smart. So that concludes our JDBC example, University Database, where we took a quick look at MySQL Server, or you can do SQLite, and some basic queries you can put in there and how that works.
So the first question, what exactly is a servlet? Now imagine you're searching for some information on the internet. You open your local browser and start typing it. This question from you to the internet is called as request. So further, this request is sent to the cloud, or in technical terms, your browser sends your request to the respective server responsible for storing for that particular information and helps you with it when requested. Now the server gets triggered with your request, and in return, it helps you back with the information you have requested for. This answer from the server is called the response. So this is how the request and response work in a server. For this process to happen so smoothly and effectively, we need a servlet. Digging a little deep into the server, we find the component responsible for such an effective job. It is called the servlet container that holds Java-based web application and a set of individual components called as servlets. Now we are close to our answer. So this particular Java-based component takes care of web request and response. To sum it up with the form of a definition, we can define it as follows. A servlet is a Java program that runs on the Java-enabled web server or application server. They are used to handle the request obtained from the web server, process the request, produce the response, and then send a response back to the web server. Now, hoping that it was a clear explanation, can we move ahead with the next topic? So the next topic we have is, so how does the servlet work in reality, or more practically or in depth, what's the life cycle of a servlet? So the life cycle of a servlet in real time has the following stages. These stages are the ones that a Java servlet actually follows in real life to get our work done. So the stages are init, service, and the CRUD operations, which are the get, post, put, delete, and finally destroy. Now let us understand each one of them in a bit more detail. The first one is the init process. The init method is called only once. It is called only when the servlet is created and not for all the requests afterwards. So it is used for the one-time initializations, just as with the init method of applets. The servlet is normally created when a user first invokes a URL corresponding to the servlet, but you can also specify the servlet is loaded when the server first started. When a user invokes a servlet, a single instance of each servlet gets created, with each user request resulting in a new thread that is handed over to the doGet or doPost as appropriate. The init method simply creates or loads some data that will be used throughout the lifecycle of a servlet. Followed by the init method, we have the service method. So what is service method? Service method is the main method to perform the actual task. The servlet container, that is the web server, calls the service method to handle requests from the client or the browser and to write the formatted response back to the client. Each time the server receives a request from the servlet, the server spawns a new thread and calls service. The service method checks the HTTP service type and accordingly performs the CRUD operations, which are the get, post, put, delete, etc. and calls doGet, doPost, doPut, do, delete, etc. methods as appropriate. The service method is called by the container, and service method invokes do get, do post, do put, and do delete, etc. methods as appropriate. So you have nothing to do with service method, but you override either with do get, do post, and other types depending on what type of request you receive from the client. So this is how the init and service methods work. Now digging a little deeper, we have the do get, do post, do delete, and do put methods. So first we will discuss about do get method. So what exactly does a do get method do? A get request results from a normal request from a URL or an HTML form that has no method specified, and it should be hardly by do get method. Followed by do get, we have do post. A do post request results from a HTML form that specifies list post as the method, and it should be handled by do post method. Similar to do get and do post, the do put and do delete options are usually used to update and delete the data when asked by the client. So to sum up these do get, do post, do put, do delete, we can consider them as CRUD operations. So do get basically gets the information what you're looking for. Do post method usually posts the information or provides you with the response from the server, and followed by that we have the do put, which is usually used to update the data which is present on your server, and finally delete, which is used to delete an existing data on your server. So these can be considered as CRUD operations. And finally we arrive at the last method, which is the destroy method. The destroy method is called only once at the end of the life cycle of a servlet. This method gives your servlet a chance to close database connections, halt background threads, write cookie list, or hit accounts to the disk, and performs other such cleanup activities. So with this we finish up the life cycle of a servlet. Now we shall understand its architecture. Basically, the architecture of a servlet can be understood by reverse engineering the lifecycle of a servlet. So this is how the servlet execution takes place when a client or a browser makes a request to the web browser. So the servlet architecture includes the following. First one, servlet interface. To write a servlet, we need to implement the servlet interface. Servlet interface can be implemented directly or indirectly by extending generic servlet or HTTP servlet class. Followed by that, the next part is request handling methods. As we have discussed before, there are mainly three methods defined in servlet interface, which are init, service, and destroy. And inside service, we have do put, do post, do get, and do delete methods. The first time a servlet is invoked, the init method is called. It is called only once during the life cycle of a servlet. So we can put all your initialization code here. The service method is used for handling the client request. As the client request reaches the container, it creates a thread of servlet object, and request and response object are also created. These request and response objects are then passed as parameter to the service method, which then processes the client request. The service method in turn calls the do get, do post methods if the user has extended the class from HTTP servlet. And lastly, the creation of instances. This is based on the load of the servlet. So with this, we have finished the architecture of servlet. Moving further, we shall quickly discuss the features of servlets and then enter into the practical mode. So the following are the features of Java servlets. The first feature is Java servlets are portable in nature. As I have mentioned above, the servlets use Java as programming language. Since Java is a platform-independent programming language, the same holds true for servlets. For example, you can create a servlet on Windows operating system that uses Glassfish as a web server and then later run it on any operating system like Unix, Linux, and Apache Tomcat web server. This feature makes servlet portable, and this is the main advantage of servlet over CGI. We shall discuss all the differences of CGI versus servlet in the next section. For now, we will discuss the features. Followed by the first feature, we will now enter into the second feature, which says Java servlets are efficient and scalable. once a servlet is deployed and loaded onto a web server, it can instantly start fulfilling the request of the clients. The web server invokes servlet using lightweight thread, so multiple client requests can be fulfilled by servlet at the same time using the multi-threading feature of Java. Compared to CGI, where the server has to initiate a new process for every client request, the servlet is truly efficient and scalable. The next and the final feature of Java servlets is they are robust and highly secure. By inheriting the top features of Java, such as garbage collector, exception handling, Java security manager, etc., the servlet is less prone to memory management issues and memory leaks. This makes the development of web applications in servlets secure and less error prone. So these were the important features of Java servlets. Now let us enter the practical mode. So we are in the practical mode right now. There were two parts in the practical mode. The first one was to set up the environment for Java servlets, and the second one was to execute a basic program. So this document has the following steps to follow. That is the prerequisites before executing a Java servlet program. So we have these prerequisites where we have to set up Java home and Java path. Followed by that we need to set up the home and path for JRE, which is the Java runtime environment, and finally Catalina home and path. So Catalina home and path is nothing but the Tomcat server home and path. Now we will set up these things by using the environment variables. Now I'm using a Windows operating system, so I'll be using the control panel to enter the environment variables. There you go, you have edit environment variables. So inside that just select environment variables, and inside this you can see that I have already set up the environment variables for Catalina home, Java home and JRE home. So now let us just select Java home and edit it so that we can see how did I set it. So you can see I have named the variable name as Java home, and inside the variable value I have a location. So this location is nothing but the Java JDK location in my local system. Now followed by that we have JRE home. So similar to Java home, we have set up the JRE home as variable name is equals to JRE home, and the variable value is the location of JRE folder in my local system. So I have my JRE folder in my local system at C drive program files Java JRE, and similarly the Catalina home, which is inside my program files Apache Software Foundation and Tomcat 8.5. So similarly we'll also check up the path variables. So inside system variables you can see the path, just edit it, so then you can see the path variables set for Java, JRE and Tomcat. Now just select OK, OK, and finally another OK. Now your prerequisites have been set up. So this is how you set them. So in case if you have doubts about the Tomcat version to download, then I'll help you with that. Just open Google and type in Tomcat download. So now you have entered Apache Tomcat official site, and since I'm using a Windows operating system, I'll be selecting the 32-bit or 64-bit Windows Service Installer version. And after this gets downloaded, you need to set up the home and path variables for Catalina server. So once after the environment is set up, you need to follow 4 stages to create a servlet program, which are creating a dynamic web project, create a servlet, add servlet API jar file and run the servlet. So to create a dynamic web project, you need to select new, and inside that you have the option of other. Just select other, and inside that you'll be finding web. So select web, and inside that you need to select the dynamic web project and select next. So you just need to name to your dynamic web project. So I'll be naming as server, then select next, and inside that you have a source folder, and now you can select finish. Now there you go. Java Eclipse will ask you for opening this particular in Java EE perspective. Then just select open perspective. Now basically Java will set up everything you need here. And there you go, you can see server folder here which has already set up everything you need. Now what you need to do is set up a new servlet. So right click this and select new, and inside that you can see the option of servlet. Just select it. Now you can see a new dialog box, and here you need to set up the class name. For now let's just type in hello and go to next. Now again next, and in here you have a lot of options. So for now we are just executing a basic program, so let's just select do get method. Now let's just finish it, and there you go, your servlet has been ready. So this is the basic template created by Eclipse for you. Now next we need to add in the build path. So for that you need to right click the server and then select build path, and here configure build path. From here you can add the external library. Select the external libraries option, and you can see I have the Tomcat libraries here. Just select all and open. And that's how you add all the required libraries of Tomcat server. Now apply and close. Now the last step is to execute the project. Now just to save time, I have already typed in the program, which is over here. Now let's try to execute this. This program will just provide us a simple output, which is none other than hello world. Now the server I have chosen is Tomcat server. Let's finish it. So there you go. The message has been displayed successfully. Hello, welcome to Simplilearn. Now we'll move ahead with our next topic. Now that we are done with the environment setup and the basic example, let us now discuss the advantages and disadvantages of using Java servlets. So first, we will discuss the advantages. The following are the advantages of using servlets in Java. Servlet is convenient in modifying regular HTML. We can write the servlet code into JSP. Servlets include the feature of multi-threading of Java. We can make use of exception handling of Java. Servlets have a separate layer for business logic in the application. And finally, it is easy for developers to show and process the information. So these were the advantages of using servlets in Java. Moving ahead, we will discuss the disadvantages of using servlets. So following are the disadvantages of using servlets in Java. Designing a servlet is considered as a little complicated. Servlets often slow down the application. Business logic of servlet is difficult to understand. We need a JRE, which is the Java Runtime Environment, on the server to run our servlets. And finally, the data connectivity is a little complicated. So these were the major disadvantages of using servlets in Java. Moving ahead, we will understand CGI. Why are we learning CGI? Because even CGI is similar to servlets, and it also does the web interactive job similar to servlets. So thought you should know about some basics of it. So let's understand its definition and architecture real quick. So the CGI, or Common Gateway Interface, is a standard for writing programs that can interact through a web server with a client running on web browser. These programs allow a web developer to deliver dynamic information, usually in the form of an HTML, via the browser. A CGI program can be written in any language including Java that can be executed by your web server. CGI programs are commonly used to add search engines, guestbook applications, database query engines, interactive user forums, and other interactive applications to websites. In very basic terms, a CGI program must interpret the information sent to it, process the information in the same way, and generate response that will be sent back to the client. Most of the input of CGI program is passed into through environment variables. So with this, we will move ahead into the architecture of Common Gateway Interface. So you can see the architecture of Common Gateway Interface is completely similar to servlet. Normally, the request is sent in the form of an HTTP request. So this particular HTTP request is divided amongst the CGI shells, and it will be processed by the CGI shells based on the program provided, and the response is sent to the user. Now moving ahead, we shall understand the differences between the common gateway interfaces and the servlet. So the first difference is the common gateway interface scripts are executable codes written in native operating system, while on the other hand, the servlets are written and run using the Java virtual machine. The next difference is the common gateway interface performance is considered to be low compared to servlets. On the other hand, servlets are having high performance compared to CGIs. The third difference is for a common gateway interface, it is hard to switch between different platforms, that is the operating system platforms. When we come into servlets, the servlets are considered to be completely platform independent. Followed by that, the common gateway interface scripts are directly executed. So on the other hand, servlets are translated into bytecode because the servlets are executed using the Java virtual machine. And in Java virtual machine, whatever the code you transfer, it will be converted into bytecode first, then executed. And the last difference is the common gateway interface is not portable. And on the other hand, we have the Java servlets to be completely portable. So these are the major differences between the common gateway interface and Java servlets. Now let us understand the Java servlets requests and responses. So first we will deal with the request phase. In request we have various types. The first one is being the HTTP request. The HTTP object is used to represent the HTTP request to a browser that the user sends to the web application. Thus, anything the browser sends is accessible through the HTTP request. Followed by the HTTP request, we have the request parameter. The request parameters are the parameters that are sent from the web browser along with the request. The request parameters are typically sent as a part of the URL or as a part of the body of an HTTP request. Followed by the request parameter, we have the request header. The request headers are the name value pairs sent by the browser along with the HTTP request. The request headers contain the information about the web browser software being used, what type of files that the web browser can receive, etc. Followed by the request header, we have the input string. If the browser sends an HTTP post request, request parameters and other potential data is sent to the server in the HTTP request body, it doesn't have the request parameters that is sent in HTTP request body. It could be pretty much as the data like file or SOAP request. The next one is the request session. The session object can hold information about a given user between the requests. So if we have set an object into the session object during one request, it will be available for you to read during any subsequent request within the same session time scope. Followed by the request session, we have the servlet context. The servlet context contains the metadata related to the application. Followed by servlet context, we will enter the response phase. In the response phase, we will deal with the first one, which is the HTTP response. The HTTP response object is used to represent the HTTP response to your request. A web application sends back a response page to the user as a response to the HTTP request from the browser sent to your web application. Followed by the HTTP response, we have the write HTML. To initiate the process of sending the HTML back to the browser, you need to retrieve the print writer from the HTTP response object. This can be done using the write HTML. Followed by the write HTML, we have the response header. Similar to HTTP request, the HTTP response includes headers as well. These are responsible for all the data written in the response. Followed by response header, we have content type. The content type header is responsible to tell the browser about the type of content you are sending in the return. Followed by content type, we have the content length. The content length header is responsible for telling you about the number of bytes your servlet is sending you in return. Followed by content length, we have redirection. Redirecting will help you to redirect yourself to the different web page from the current one. So these were the HTTP requests and responses in Java servlets. Now we will enter the next part where we will deal with the session tracking and cookies. So first, we will understand session tracking. Session simply means a particular time of interval. Session tracking is a way to maintain state or data belonging to a user. It is also known as session management in servlets. HTTP protocol is stateless, so we need to maintain state using session tracking techniques. Each time the user requests to the server treats the request as a new request. So we need to maintain the state of a user to recognize a particular user. You can understand this in a better way by looking at the picture showed on the presentation. Each time you send a request, you will be receiving a response from the server, as well as this particular request will be recorded as a state in order to recognize you as a particular user. Now after session tracking, we will enter into cookies. Cookie is a small piece of information that is persisted between multiple client requests. A cookie has a name, a single value, and optional attributes such as comment, path and domain qualifiers, a maximum age, and a version number. By default, each request is considered as a new request. In cookie technique, we add a cookie with response from the servlet. So cookie is stored in cache of a browser. After that, if the request is sent by the user, the cookie is added with a request by default. Thus, we recognize the user as an old user. There are two types of cookies. They are non-persistent cookie and persistent cookie. Let's understand non-persistent cookie first. A non-persistent cookie is valid for a single session only. It is removed each time when the user closes the browser. Now, let us understand the persistent cookie. The persistent cookie is valid for multiple sessions. It is not removed each time when the user closes the browser. It is only removed when the user logs out or signs out from the browser. So before we begin with what exactly is a Java API, we will understand what Java is. So basically, Java consists of two major components that are Java Runtime Environment and Java Development Kit. So when we get into Java's API, we might want to dig a little deep into Java's Development Kit. So JDK consists of three more major components that are the Java's compiler, Java Virtual Machine, and APIs. Now we will learn each one of them in a bit more detailed way. So at first we have the Java's compiler. So Java compiler can be defined as a software program that is designed to convert the high level, that is the user return or user readable code, into the computer readable code, that is the machine level or byte code. So this particular byte code will be transferred to the next state where we find the JVM. So what is JVM? So JVM is an abbreviation for Java's Virtual Machine. So Java's Virtual Machine is responsible for processing all the byte codes and providing an output to the user. Next, we find our topic for today's discussion, that is the Java API. So just like Java's virtual machine and compiler, Java's APIs are the integral software packages that come with the JDK. The primary intention of API is to establish communications between different applications. So on my screen you can see a pictorial representation of Java API's architecture. So at first we have the Java's program on the topmost layer. So this particular segment will be having the user return program in user language. Followed by that, we have the interpreter, Java's API, and the Java's virtual machine, which are responsible for reading and compiling the Java's program. So at the last final level, we have the application hardware, which is responsible for interacting to the Java's program. So this is how the Java API's architecture looks like. Now followed by this, let's dive into the next topic. So in the next topic, we find the types of developers using various types of APIs for different jobs. So at first we have the open developers, next we have the internal developers, and at last we have the partner developers. Don't worry, we will understand each of these developers in a bit more detail and along with some examples for a better understanding. So at first we have the open developers. So open developers are used by top-end companies. So leading companies provide access to their APIs as open source through authentication via a unique secret key to keep track and ensure the legal usage. So basically what happens here is there might be some big companies like social media companies or some more other companies which provide the API they use for their applications as open source to the developers. So these open developers get access to their APIs through getting authentication. So they'll be creating a profile, they'll be providing the research details of their application, like what are they using that particular API for and other reasons to use those APIs. Then they get the unique secret key from the owner of that API. And That's done just to keep track that the API provided is not misused. So the open developers majorly include the B2C teams, and some of the major companies that provide the APIs for open developers are Twitter and Telnix. So one best example is the Twitter, where the Twitter provides Twitter API for the Twitter developer accounts for using that for any kind of developing things or some data science applications and much more. So followed by the open developers, next we have the internal developers. So you can consider internal developers as an organization. So the internal developers belong to a specific organization and work in a closed environment. These APIs run with a high security that can establish communication between the application and the application hardware. So only the internal developers, that is the developers belonging to that particular organization, have the access to that particular API. So this particular type of APIs run on a high security level. So internal developers majorly include B2C teams, B2B teams, A2A teams, and B2E teams. So some of the major companies that provide the internal APIs are Instagram, Google Mail, and Google Cloud Virtual Machines. Next we have the partner APIs. So the partner developers are similar or like internal developers, but the only difference is there is a collaboration between two or multiple companies. For example, consider yourself to be linked with a different company and you both wanted to create an application. So only you both can have access to that particular API that you're using to create your application. So partner developers majorly use the B2C teams, and the major companies providing the partner APIs are Microsoft and Finextra. So with this, we finish the first topic, that was what is API and who exactly uses it and for what purposes. Now we dive into the next segment where we learn the need for Java APIs. So why exactly we need Java APIs? Now Java APIs are used for multiple reasons. But the three most important reasons for which we use Java APIs are to streamline the operations, improvise the businesses, and finally create some powerful applications. We will discuss each one of them in a bit more detail. So the first one is to streamline operating procedures. We have multiple social media applications like Twitter, Facebook, WhatsApp, etc. Followed by that, we have multiple delivery applications such as Amazon, Flipkart. Then we have the F&B such as Zomato, Swiggy, etc. So all these applications are running smooth and hassle-free because of the significant improvement in the implementation of Java APIs. By using Java's APIs, users are provided with multiple options on the screen. So this kind of approach makes the functionality very simple and easy to use. Followed by this, the next important requirement is to improvise the business. Introducing APIs to the public leads many companies to release private data to generate new ideas, fixing existing bugs, and receive new ways to improvise operations. The Twitter developer account is an example for API that gives programmers private API keys to access Twitter data and develop applications. Followed by that, we have the third one, which is to create the powerful applications. Online banking has changed the industry forever, and APIs offer the customer's ability to manage their finances digitally with complete simplicity. So this is made possible only by the use of APIs. Now followed by this, we will dive into the next topic where we understand the types of Java APIs. So basically there are 4 different types of APIs in Java. They are public, private, partner, and composite. We will discuss each one of these APIs in a bit more detail. At first, we will deal with the public API. So what are public APIs? Public means open. So public or open APIs are Java's APIs that come with the JDK, and they do not have any strict restrictions about how developers use them. So followed by the public APIs, we have the private APIs. So the private or internal APIs are developed for a specific organization. These particular APIs will be accessible through the authentication by only the employees belonging to that particular organization. So followed by private APIs, we have the partner APIs. So similar to private APIs, even partner APIs are having some authentication process to use. So The only difference is here, instead of one organization, we might have two or multiple organizations, and the employees belonging to that particular group of organizations will be able to access the APIs and implement them or use them. Followed by partner APIs, we have the last one, which is the composite API. Composite APIs are microservices, and developers build them by combining several service APIs. Now that we have covered the different types of APIs, let us now discuss the categorization of Java APIs based on the services that different varieties of APIs in Java provide. So data and API services are another way to categorize Java APIs other than the previous type, which is the public, private, partner, and composite. APIs are also classified based on their data manipulation capabilities and the variety of services they offer. So this type of categorization has 4 different types, which are the internal API services, external API services, CRUD operations, and user interface services. We will understand each one of them in a bit more detail. At first, we will understand internal API services. Internal API services are developed to offer organizations services specific to that particular organizations. These services include only complex data operations and internal processes. Followed by internal API, we have the external API. External API are open source APIs that developers integrate into existing application or website. So internal APIs are something similar to private APIs, and external APIs are something similar to public APIs. Next, we have the CRUD operations. So CRUD APIs provide data manipulation operations over various data storage units such as software and service, that is SaaS, and relational database management systems such as RDBMS, using standard data storage unit connecting tools like database connectivity, that is JDBC, etc. Next, we have the user interface services. User interface service APIs are open source APIs that allow developers to build user interfaces for mobile devices, computers, and electronics. Now let's examine the rules and protocols that Java APIs must follow. So that brings us to API service protocols. The rules and protocols guide the different functionalities of Java APIs. So different APIs have different service protocols. Let's consider an example for RESTful API service protocol as an example. So for a typical RESTful API, developers must follow the following rules. For a typical RESTful API, developers must follow these rules: stateless, uniform interface, client server, cache, layer. No worries, we will discuss each one of these protocols in detail. First, we will discuss stateless. So what exactly is stateless? So since the RESTful API follows client-server architecture by default, it is recommended that RESTful API services to be stateless all the time. Next, we have the uniform interface. The entities in a RESTful API are server and clients. Applications that run on global scale need uniform client and server interface through Hypertext Transfer Protocol or HTTP, and Uniform Resource Identifiers URI will allocate the required resources. Next, we have the client server. The client-server model used in the RESTful API should be fault-tolerant. Both the client and server are expected to operate independently. The changes made at the client end should not affect the server, and vice versa. Next, we have the cache. Including a cache memory allows the application to record intermediate responses and run faster in real time. A RESTful API also includes the cache memory. And next, we have the layer. A RESTful API is built using layers. Layers of API are loosely coupled or independent from each other. Each layer contributes a different level of hierarchy and also supports encapsulation. Next, we will go through some frequently used APIs. So this is the list of most frequently used APIs in real time. So we have Web API, Facebook 4J, Twitter 4J, Android API, Java Advanced Imaging, Java Data Objects, and you can also see the acronyms for them in the right column. So some of them have no acronyms and some of them have acronyms. For example, we have Android API as Google, Java Advanced Imaging as JAI, Data Objects as JDO, etc. So moving into the next slide, we have a few more APIs. So we have RESTful APIs, Java Media Frameworks, Java Persistent APIs, Java Speech API, Java 3D, Java USB for Windows, etc. And similarly on the right column, we have their acronyms. So for Java Media Frameworks, we have JMF. For RESTful APIs, we have nothing. and Java 3D we have J3D, Java Speech API as JS API, and few others. So followed by this, we will advance into the next topic where we will discuss about the advantages of using Java's APIs. Now, using Java's APIs will help you with multiple advantages. Now we will discuss the most important advantages of using Java's APIs. So the first one, we have the extensive SQL support. APIs in Java enable a wide range of SQL support services in users' applications through a component-based interface. Next, we have applications. APIs in Java provide effortless access to all of an application's major software components and easily deliver services. Next, we have efficiency. Java's APIs are highly efficient because they enable rapid application development. Also, the data that the application generates is always available online. Next, we have the automation. API allows computers to automatically upload, download, update, and delete data automatically without human interaction. Followed by that, we have integration. Java APIs can integrate to any application and website and provide a fluidic experience with dynamic data delivery. Followed by that, we have scope. Java's APIs make websites, application, and information available to a wide range of users and audience. Followed by that, we have customization. Java APIs enable developers and businesses to build applications that personalize user interface and data. And finally, we have the adaptability. Java APIs are highly flexible and adaptable because they can easily accept feature updates and change to frameworks and operating systems. What exactly is Java Enterprise Edition? The Java EE stands for Java Enterprise Edition, which was earlier known as J2EE and is currently known as Jarkataka EE. The Java Enterprise Edition provides a platform for developers with enterprise features such as distributed computing and web services. Now let's move further and understand why exactly we needed Java Enterprise Edition. We needed Java Enterprise Edition for 4 major reasons. To have powerful API support, to reduce development time, to reduce application complexity, and finally to improve the application performance. So followed by the need for Java Enterprise Edition, we will move ahead and understand the Java Enterprise specifications. So in the Java Enterprise specifications, we are going to discuss the 4 major specifications used by enterprise developers. So the first one being the enterprise specification, followed by that we have a web specification, then we have web server specification, and finally some other miscellaneous specifications. We shall discuss each one of them in detail. Firstly, we will move ahead with enterprise specification. So in enterprise specification, we have the first one to discuss, that is the context dependency injection. The context dependency injection provides a container to inject dependencies as in swing. Next we have Java Enterprise Java Bean. The Enterprise Java Bean is a set of lightweight APIs that an object container possesses in order to provide transactions, remote procedure calls, and concurrency control. Followed by Java Bean, we have Java Persistent APIs. So the Java Persistent API are the specifications of object relational mapping between relational database tables and Java classes. Next, we have the Java Transaction API. It consists of Java interfaces and annotations to establish interaction between Java transaction support offered by Java Enterprise Edition. The APIs in the abstract from low-level detail to the interfaces are also considered as low-level. Followed by Java Transaction API, we have the Java Servlet. The Java Servlet specifications define how you can manage HTTP requests either in a synchronous or asynchronous way. So followed by Java Transaction API, which is one of the enterprise specifications, we will move ahead into the Java Web specifications. So the first one in the Java Web specification is the Java Servlet. So this specification defines how you can manage the HTTP request either in a synchronous or asynchronous way. It is low level and other specifications completely depend on it. So followed by Java Servlet, we have the Java WebSocket. So the Java WebSocket is a computer communication protocol, and this API provides a set of APIs to facilitate WebSocket connections. Followed by WebSocket, we have the Java Server Faces. So the Java Server Faces is a service which helps in building graphical user interface out of the components. So followed by Java Server Faces, we have the Unified Expression Language. The Unified Expression Language is a simple language which was designed to facilitate web application developers. So followed by the web specification, now we will enter the web service specification, out of which we have the first one, which is the RESTful Web Service. So the Java RESTful API Web Service provides services having representational state transfer schema. Next, we have the JSON processing. Java API for JSON processing is a set of specifications to manage the information provided in a JSON format. Followed by JSON processing, we have JSON binding. So the Java API for JSON binding is a set of specifications that provide for binding or parsing a JSON file into Java classes. Next, we have the XML binding. So XML binding simply allows for binding of XML into Java objects. For example, SOAP is an XML-based protocol to access web services over HTTP. This API allows you to create SOAP web services. So followed by the web service specifications of Java Enterprise Edition, we finally enter into the other miscellaneous specifications of Java Enterprise Edition. So out of that, the first one is the validation. So the validation package consists of various interfaces and annotations for declarative validation support offered by Bean Validation API in Java. Followed by validation, we have the batch applications. So the batch applications provide the means to run long-running background tasks which involve large volume of data and which need to be periodically executed. Followed by batch applications, we have Java Enterprise Connector Architecture. So the Java Enterprise Edition connector is a Java-based technological solution for connecting Java servers to enterprise information system. So with this, we will enter into our next step, where we will learn the system requirements to install Java Enterprise Edition. So the basic requirements to install Java Enterprise Edition into your local system are: you should be having the Java virtual machine from the standard 6th edition or more. Followed by that, your local system should be having at least 1 GB of RAM capacity. Next, your system should be having at least 250 GB ROM space available. And finally, you should be having the Java Development Kit installed into your local system. Now next, we will understand how to install Java Enterprise Edition into your local system. So in short, these are the steps you need to follow to install Java Enterprise Edition into your local system. First, you need to browse into the Oracle official Java site, then go to Java Standard Edition Development Kit. Followed by that, accept the license terms, download the JDK file, run the JDK file as an administrator in your local system, then set up the Java environment. I know this looks a little bit complex, but don't worry, I will drop a link in the description box below which will explain you in a much detailed way how to install Java into your local system. Please check that to have a better understanding of how to install and set up Java in your local system. So followed by this, we will learn the differences between the Java Standard Edition and Java Enterprise Edition. So the first difference between the Standard Edition and the Enterprise Edition is the Standard Edition provides basic functionalities like defining classes and objects, whereas Java Enterprise Edition mainly focuses on high-end and corporate type of Java applications. The second difference between the both is Java Standard Edition comes with only the standard specifications which will be used by a beginner. And similarly, on the other hand, Java Enterprise Edition comes with some advanced specifications which support web applications and servlets. The third difference between the both is the Java Standard Edition comes with features like class, libraries, and deployment environments, whereas the Java Enterprise Edition has structured application with the client's business and enterprise layers. The fourth difference between the both is the Java Standard Edition is used for desktop and mobile application developments, whereas on the other hand, the Java Enterprise Edition is used mainly for development of web applications. The fifth difference between the both is the Java Standard Edition is preferred and used by beginners. And on the other hand, the Java Enterprise Edition is preferred and used by experts in Java field. The sixth difference between the both is the Java Standard Edition does not have authentication, whereas on the other hand, there are strict rules and regulations to be followed when using Java Enterprise Edition related to authentication.
What is JUnit? JUnit is an open source unit testing framework for Java. Here, the term unit testing framework comes into consideration. So before moving forth, let's check what is meant by the term unit testing. Unit testing, as the name suggests, is a way of testing a unit. Here, a unit refers to the smallest piece of code that can be fetched out of the system. It can be a line of code, a method, or a class. Keep in mind, smaller the chunk of code, the better it is. If the tested units are small, the tests tend to run faster, providing a better insight into the code and its performance. Unit testing helps in the early identification of defects. It enables the developers to spend more time on reading the code rather than writing it. And a successful code helps in boosting the confidence of the developer. Then coming back to JUnit, the framework is used by Java developers to create and test their codes. It is used for unit testing of the source code, and JUnit works on the approach of testing a small part, then coding that, and continuing the same till the end. JUnit testing helps developers to develop more reliable, readable, and a bug-free code. Every time a new code is added, all the test cases have to be re-executed to make sure that nothing is broken. There are graphs in JUnit that show the progress of the test. The graphs show green when the test runs smoothly and it turns red when the test fails. Now, when we know about JUnit, let's see the way to download and install that into our system. Before you go on to install JUnit, make sure you have JDK and Eclipse installed in your computer system. So, let's go on. First, open your browser. In the browser, type download JUnit. In download JUnit, we'll get about JUnit. In about JUnit, when we scroll, we find download and install. In download and install, when we go inside that link, we will find two jar files. Here, let's download these two jar files. When we click on this download button, we will download jar. After the first jar is downloaded, let's go back to that page and download the second jar file. After both the jar files are downloaded, let's go to the location. Here we can see two of our jar files are downloaded. Let's copy these jar files, go to our documents, and here in the Java libraries, where all the Java libraries are stored, let's paste them. After we have pasted these files, we shall open our Eclipse. As soon as our Eclipse opens, we will first create a project. Here, new, then we shall create a Java project. In Java project, let's name it JUnit installation. Click on next and finish. Here, then in this Java project, right click on it and go to the build path option. In the build path option, go to configure build path. Here go to the tab libraries, and this side go to add external jars. In add external jars, you will get the location of our two jar files, and if you don't get them, you can browse to the location where you have stored them, or to the location of Java libraries. Then select these two files and open them. You will see the two jar files appear here. Then click on Apply and Close. Now come back to JUnit installation, that is a project, right click on it and click on Refresh. Then right click on the src folder, go to New and create a package. Let's name the package to be JUnit install and click on Finish. In this package, create a new class and we shall name the class JUnit install and click on Finish. Now let's create a method over here. In the method, we shall type public void my JUnit install then system.out.println welcome to my JUnit testing. Now I will add a library over here, library test. I can see a error. Now when I hover over this library, I can see it says import test. So now when I click on it, the error is gone. Now we shall run our test, and since we are testing with JUnit, we shall click here, go on, run as JUnit test. Here we shall click on OK, and then we can see in the console it shows welcome to my JUnit testing, as we had placed it over here. Here on the left side you can see the JUnit report. You can see runs 1 out of 1 and there is no or 0 errors, and same there are 0 failures. So here in the space provided, you can have as many number of tests, as many bunch of code you want, and with the help of JUnit, you can test any particular part of the code.
The top 10 Java project ideas. So, the first project that we will deal today is the online courier management system. So this particular project motto is to deal with the courier management system. The system will be used for day-to-day activities like buy, return, booking, delivery and non-delivery, and self-pickup, etc. It is not easy to build this particular project all alone, as the technicality of the project is a little complex for a single programmer. I would suggest you that you get a team with you and also look out for some automation in the process by developing the relevant software. Robotic process automation is the new normal in today's life. The web-enabled interface allows the user to log in from anywhere in the world and track their courier and also view the customer rating. The system is designed to integrate with financial accounting to eliminate duplication of data entry and is also scalable to grow along with your company. The system needs to be built with user-friendly screens, rich in functionality and features, and finally the major part, it should maintain a high level of data integrity. So with that abstract discussed, now let's look into the features offered by this particular online courier service. As discussed in the abstract, this particular project should be providing the features of order and dispatch of the product, information regarding the customer, delivery executive, and followed by the delivery executive, we should be also having a payment window which manages the accounts and bill reports. So having said that, let's now move into the software requirements. So the software used in this particular project is the programming language, that is Java. Database is the Microsoft Access and some convenient RPA tools. And finally the IDE. The IDE for this can be any one which has a good support for Java. The most preferable one would be the Eclipse. And then comes the IntelliJ, NetBeans and many more. Now, creating this kind of a project will give you a valuable experience based on building a fully fledged e-commerce website or an application. I mean, this is how the world's leading applications like Amazon, Flipkart, Zomato, etc. are basically planned and have reached greater heights today. This kind of project on your resume could make a huge difference. And who knows, tomorrow you might even get into one of those companies and start working on their projects or build a company of your own. Followed by the online career system, we have the online voting system. Now, thinking apart from getting a job or starting a new company of your own, this is something that we all need today in this pandemic situation especially. In the current scenario, the internet has brought all the ease to our living room. It has replaced physical banking to internet banking, ordering food online, buying movie tickets, buying clothes and household items, to consult your doctor for minor issues, bill payments, and many more. Yet, for quite a long time, going to polling booth and standing in a long queue to cast a vote has been persistent, and it has been challenging for the government to motivate common people to participate in the election system and cast their vote, just because there is no other way to do such thing as such an online voting system. But all the credit can be achieved by software engineers who can make it possible soon for everyone to cast their vote to their respective candidate as their own choice with an unmatchable ease. This can be done just by click on their fingers. This is an advanced Java project developed to show online voting functionality. Followed by the abstract, we will get into the technicality of this particular project. So the first phase of this particular project has the admin phase, where the admin has the right to manage the candidates, manage the voters and their profiles and passwords, and finally election results. Followed by the admin, we have the voter or the user of this particular application. The voter or the user gets to register himself or herself into the application. Followed by that, he can use the login and logout options. And next we have the profile and password managements. So followed by that, we have the option to choose the positions to vote, and finally to cast the vote. Now this particular project is an advanced level Java project developed to show online voting functionality. It showcases the use of Java servlets, HTML and CSS. Again, coming into the IDE. The IDE for this can be anyone who has good support for Java. The most preferable one would be Eclipse and IntelliJ. Followed by the online voting system, we will now continue with the online healthcare management. Named as the corporate Medicare management, this e-healthcare management system is a web-based project developed in Java. The main aim of this particular project is to provide effective management of data related to staff and patients in hospitals or clinics. The features offered by this particular project should be as follows. It should optimize bed occupation. The project should improve the use of operation theaters, avoiding the cancellation of operations. To know how much emergencies affect the administration of the hospital departments or services which include cancellation of operations. To optimize the allocation of human and material resources to wards and shifts. To detect the influence of certain diseases in the hospital services, and finally to find clusters of patients. The software requirement for this particular project are as follows. We need DHTML for the front end and Java as the programming language, and data mining tool which is Weka, and Oracle for the database, JavaScript for the scripting language, and finally Tomcat as our server. The e-healthcare management system is a web-based application that assists the management of staff, doctors and patients in an easy, comfortable and effective way. Here, the concept of data mining plays a vital role to develop an effective healthcare management system. The proposed application aims to create a friendly working environment for any healthcare centers to overcome the drawbacks in the existing system of healthcare management. This system is very reliable and flexible from all aspects, so new features and modules can be easily integrated into the system in the future. Followed by the e-healthcare management system, we have a new normal, online banking. Not interesting and arousing for a normal person, but for a hardcore programmer, it is as exciting as a roller coaster ride in an amusement park. Because this is how the major national and multinational banks implement their banking facilities in a wide range so that their customers could experience the ease of banking at their fingertips. One such type of project on your resume could bring major highlight to the recruiter, especially if the recruiter is from a banking or financial based company. Online banking system project is a model internet banking site. This project should enable the customers to perform basic bank transactions by sitting at a corner of their home or office through a phone or laptop. The customers can access bank's website for viewing their account details and perform the transactions on account as per the requirement. Bank employees can log in and add customer and account information to perform transactions with internet banking. With internet banking, the brick and mortar structure of the traditional bank gets converted into a click and portal mode, thereby giving the concept of virtual banking a real shape. Thus, today's banking is no longer confined to branches. E-banking facilities banking transactions by customers round the clock globally. The features you can offer through this particular project are homepage for online banking site, creation of new accounts, login and log out, manage profiles and passwords, view the balance of the account, deposit the amount into the selected account, withdraw amount from the selected account, transfer the amount from one account to another, close the account. So the software requirements for this particular project are Java programming language and JavaScript for scripting language and Oracle for database and Tomcat for server. So followed by the online banking project, we have the online examination project. Online exams are normal for us nowadays, but this is totally limited to high-end exams like CET, GRE, CAT, etc. The requirement for this particular project is increasing day by day because of the current scenarios. Many schools and colleges have now turned towards the online education system and are looking forward to hosting online exams for student safety. Online examination is a simple project developed to provide an online platform for faculty and students to conduct online examinations and their evaluations. This particular project has two parts. First is the admin part. Admin has the right to add students, create one-time login, adding questions, receive answers, and finally to evaluate. Followed by the first part, we have the second part, which belongs to the students. So the students can log in, update their profile and password, select answers for the MCQs, write answers to questions, and finally closing the session and log out. This particular project can be made a grand success by making use of simple Java servlets and Java programming languages and server like Apache Tomcat. Followed by the online examinations, we have the Smart City. Smart City Java project can be a web-based software developed to store the details of a particular city. The main purpose of the project is to help tourists and other visitors to a city by providing information about hotels, transportation facilities, air ticket booking, shopping details, city news, etc. The Smart City Java project serves the visitors as a guide of the city, and hence the project is called as City Guide Project in Java. Using this project, the details of the city can be accessed from anywhere at any time. The implementation of this city project promotes tourism and business effectively. Hotels can be searched more easily from anywhere. With the help of this online software, students can look out for academic institutes located in the city. You can view the complete map of the city using this project. Followed by the abstract, we have the features of this particular project. The features offered in this particular project are login, update profile and password, search for the options, select an option like booking a ticket or hotel or anything like transportation, etc. And finally selecting that particular option, booking that option and payment window. Finally, the confirmation of the order. This particular project can be fulfilled by using the following software tools as mentioned below. They are the Java programming language, Tomcat server, scripting languages like JavaScript, etc. and database as Oracle for interactive data storage. This could be escalated to another level by following. Design drones that can act like a cop, act as a tourist guide for the people touring the city, a drone that has capability to take pictures, videos of suspected activities and store it for future reference. A drone can intimidate a cop if any suspected activities are detected. There can be many drones in the city with different functionalities, and finally you are required to implement the functionality of the drone to the users to interact with the drone. Users could be travelers or cops or travel agents or cab agents. The code for all these projects are provided in the description box below. Followed by the Smart City, we have the bug tracking system. The bug tracking system is a web-based application developed by Java programming language for software companies. The main aim of this project is to manage the errors or bugs that occur during the software development phase and cycle. After the implementation of this project, the employees can update the issue details, solve the issues, and update the system for any location with internet access. Below are the features of this project, and source code of this project is linked in the description box below. Coming into features, the software is applicable in managing the bugs that occur during the development of software and tracking the older issues. It facilitates searching the facility to bug history and solution. The system is fully secured and authentication method is adopted to manage security. It stores the older bug reports so that they can easily be solved when they reappear. The application helps the project manager in evaluating the works of the employees. And finally, the proposed software is capable of auto update when the latest version is available. So the software requirements for this particular project are programming language, which is Java, web-based applications such as JDBC, JNDI, servlets, JSP, and Oracle database or Access database as the database. Followed by that, the server deployment is Red Hat, JBoss, AS, etc. And the client-side scripting as the JavaScript. And the IDE for this particular project would be Eclipse with all the My Eclipse plugins. And finally, the user interface can be designed using HTML and CSS. So with this, we can move ahead into the next project, which is the facial recognition. The face recognition with OpenCV is an open source computer vision library that has tons of modules like object detection, face detection, and augmented reality. The major features that this particular project offers are managing the use of faces, facilitate face identification, easy login and logout, store face IDs, identify suspects with just images, enhanced way to find cyber criminals. So followed by the features, now we should look into the software requirements to build this particular project. So the programming language we need for this particular project is Java, and followed by the programming language we need the Apache Ant framework, Ming W64, and finally the CMake framework. So followed by the facial recognition project, we have the next project, which is the vehicle recognition. So Java ANPR is a number plate recognition software which implements algorithmic and mathematical principles from artificial intelligence, machine vision, and neural networks. So the features offered by this particular project are high-level language for numerical computation, interactive environment for iterative exploration, mathematical functions, built-in graphics, functions for integrating MATLAB, and many more. So this particular project can be fulfilled by using OpenCV and Java programming language along with some natural language processing algorithms. So followed by vehicle recognition project, we have our last project, which is the speech recognition system. So speech recognizer converts audio to text. Java x.speech.recognition package defines the recognizer interface to build speech recognition plus a SNR, commit changes, and finally provide the process results. So this particular library is readily available in Java, and you can code this project using the Java programming language and an IDE such as Eclipse.
Python is a very popular programming language for application development, data analytics, machine learning, as well as AI.
Hello everyone, and welcome to our course on Python programming. My name is Anish Karan, and I will help you learn the fundamentals of Python programming and what programming in Python really means and what it is all about. I am sure there are plenty of you over here that are watching this video that have their own reasons and multiple reasons to start learning programming and programming in Python in particular. Our goal over the duration of this course is to ensure that you are able to learn Python and learn Python programming to a level in which you can tackle whatever problems you have and whatever projects you set out to do in the future. Now, I'm sure you must have heard that there are some of the most upcoming fields and some of the high prospect domains in the market right now, such as data science, AI, machine learning, require Python programming. And our goal in this course is to get you to a level where you can start tackling and creating solutions to whatever problems you may occur, whether it be in your job or in your studies or anywhere else, or any personal projects that you may take up in the future. Now, before we actually get started, on the actual concepts and the fundamentals of Python, I want to show you over the next 2 or 3 videos exactly how Python came to be, what was the philosophy behind creating this language, and basically a brief introduction behind Python and Python programming. So Python programming was developed first by a Dutch programmer by the name of Guido van Rossum, and Python was first released by him in the year 1991. Now, the design philosophy behind Python was to create a language which was much easier to read and much easier to actually code in compared to or in contrast to the languages that were prevalent back in those days, such as the language C. Now, formally, Python is an interpreted high-level general-purpose programming, and what this means is that Python is a language that can be used for a wide variety of applications, as we will see later. The high-level part of this definition basically tells us that Python is written in a language that is very abstract, at a much higher abstract level compared to the instructions that a computer can actually read. So in layman's term, you can say that Python is very close to the actual language that we humans use, and that's the way Python has been designed. And the difference between a high-level programming language and a low-level programming language is that low-level languages are essentially machine language instructions that are the actual instructions that a computer can actually understand. A high-level language like Python is something that we humans understand better and we can write in it better. Now, the term interpreted over here essentially means that we don't need to compile our instructions that we give in Python. Now, as I mentioned earlier, that the computers or any system that involves computing needs low-level language to be fed to it so that the computer can actually understand, because computers cannot understand the way we write our code. And this process of converting from high level to low level is called compilation. And in most languages such as C, there's a special process involved called compilation, which we do after we create our blocks of code or scripts or whatever. Now, when we say Python is an interpreted language, what this means is that we can actually work on Python and see the results right at the get-go. We can skip this step of compilation because our system that runs Python actually does all of that conversion from high level to a low level language as we type our code. And this actually speeds up the process very well for us and makes programming in Python and other interpreted languages as well much easier for us. Python is of course an open source language. It's the most bare implementation of Python, known as CPython, is actually even currently being maintained by a foundation known as the Python Software Foundation. So essentially Python is being maintained, developed by a group of very talented developers, and it's open to pretty much anyone to work with and to create libraries for. This allows Python to be an amazing language in the modern world, because in the modern world we have different issues and different problems in different spheres and domains that we would need to update our libraries or update our packages that we use in our programming language on a very regular basis. And so Python, being an open source language, allows us to keep updating and keep up with the times essentially when it comes to solving problems. Now let's go over some of the features of Python, and these features are actually why it's considered that using Python is advantageous over using other languages. So let's start with some of these points. Now, as we mentioned, Python is it's a very readable program. Code readability is very important. It's one of the design philosophies behind this when it was being developed. It's very easy to learn, which is why Python is an entry point for many people that are just beginning to learn programming. And as I mentioned earlier, it's a high-level language. In Python, since Python is open source, as I had already mentioned, so it benefits from all the benefits you get from any open source technology. Now, it's also portable. So what this means is that if we create a code in Python and we create it in a particular system, say on Windows, we don't need to make any changes if we wanted to use the same script or that same piece of code on some other system, say on a Linux system or a Mac system. Python itself comes with a very large standard library. This facilitates us a lot because we don't need to create our own libraries or modules or have to download very specific libraries. Most of the problems that we do encounter quite commonly can already be solved by the standard libraries that have already been provided by the developers of Python right from the beginning. Now later on during the course, we will encounter what is the meaning of a data structure. A data structure is essentially manipulation of an object of data, and as you will see later, Python has one of the most user-friendly data structures that can be found in any language, especially compared to some of its contemporaries. Now, Python is a dynamically programmed language, and this is very important. And what this means is that in most compiler-based languages, there are certain processes that can only happen during the compilation stage. So what a dynamic programming language does is it takes all those compilation-specific tasks and processes, and it does it for us as we actually type the code. So we don't need to waste time or spend extra time to do something that would otherwise be needed to be only done in compilation. We would have to set out specific runtime just for that. So this allows us to create our programs and solutions much faster, and allows us to debug much easier. And so it's a very important feature about Python. Now quickly I will just go over some of the areas of Python where, like, areas of or different domains where Python is very heavily implemented. And the first few ones that come to mind are like web development and AI and machine learning. So you have technologies like Django and Flask that are built on top of Python that are used extensively for web development. When it comes to something like artificial intelligence or machine learning, you have distributions such as Anaconda, you have Pandas, and many other libraries like SciPy and NumPy that are used extensively to tackle problems in this domain. And similarly, Python finds use in most of the scientific work that goes on nowadays because of, again, some of the libraries that I have already mentioned, such as SciPy. Interestingly, if you are into game development or gaming in general, you would see that Python actually has certain libraries and certain technologies that facilitate game development very, very well. One very popular game, if in case you are into gaming, is a World of Tanks that is built on Python. Some of the other applications are, of course, desktop, creating desktop GUIs, image processing, graphic design applications, and something that is very relevant to me and of course you as well is creation of education programs and training courses. There are many technologies in the environment of Python that were almost designed for the specific purpose of being able to present certain concepts or to be able to teach certain classes. And I can't think of too many programs or too many environments outside of Python that are better to solve these education and training course related problems and situations. So I will show you how to install Python on Windows, since I have a Windows system. However, I will also point out the way you would have to install Python on Mac OS or Linux or even on mobile. So let's get started. So to install Python on your Windows computer, it's as simple as going to the website python.org and selecting the downloads section. When you do click on downloads, you get redirected to this website, this web page that I'm on out here. By default, it will ask you if you want to download Python 3.9, which is the latest version. But of course, if you, for whatever reason, if you needed a particular version of Python, you can download that as well by just scrolling down and choosing the option that you want. Now, it's important to note that whatever option you choose, of course, I would recommend the latest one, but no matter what option you choose, I would recommend you choose a version of Python 3 point something, because previous versions of Python, namely Python 2.7 and basically every version of Python 2 point something it will not receive any more maintenance and updates because the developers have decided that Python they are trying to shift towards maintaining and updating Python 3 point whatever completely right now. So yeah, let's not delay this any further, and let's just download Python 3.9. So once you select the option out here, you'll get an installer. All you have to do is click on that, and it'll give you two options: to customize installation or install now, I would of course recommend just do install now. Since you're a beginner, do not worry about what a custom installation is. If you have multiple drives in your system, by default the Python will be downloaded into the drive where your Windows is actually installed, your main drive. So as you can see, now that once my setup is done, it should give me a pop-up soon. So my setup is done for Python, and this is essentially how you would download Python on your Windows system. But what if you had Mac OS, or if you were using Linux? Well, for Mac, it's actually almost as simple. You just go, if you see out here below this download button, Python option, you get the website asking you, are you looking for Python on a different OS? And it gives you the options of Linux, Mac, and even other OSs. But for Mac, if you wanted, you would just open this tab, and just like the Windows option, you would choose a version and you would choose an installer for that version. So if I wanted, say, Python, the latest one, I would just download this installer and I would install on my Mac system. Now, when it comes to Linux, I cannot show you exactly how you would install it. There are certain commands that you have to execute, but essentially, again, if you would just choose the Linux option out here, it would take you to a page with different installers and essentially packages for Linux systems in specific. What I would recommend to you, if you are a Linux user and you need Python, is to go over to the realpython.com website, and they have a very good essentially instructions on how to install Python. And since I don't have a Linux system, I cannot directly show you how to install Python on Linux. So yeah, if you do have Linux, please head over to this website, and this should be of a lot of help to you. Now, as I had mentioned, you can actually install Python on your mobile devices as well. So if you were, say, an iOS user, you would go to the iOS App Store and download an app called the Pythonista app for iOS. It essentially is like a full-fledged Python environment where you can develop in Python on your iPhone or even iPad. And if you were an Android user, you would go and download an app called the PyDroid 3. There's a free version and a paid version for this app. And of course, the difference between the free and paid is that the paid supports code analysis and code prediction. These are certain details you don't have to worry about right now. And honestly, if I wouldn't worry too much about installing Python on your mobile devices currently, since I am assuming most people would be learning programming in Python on their PCs or laptops. Now that we've mentioned how to install Python, what I had actually shown you was installing what is called an implementation of Python on your system. An implementation is essentially a program or a software or an environment that allows you to actually work in Python. So what I showed you was how to install the by default or the most basic or reference implementation that has been created by the developers, which is actually called CPython. Even though you would not have seen the letter C or the prefix C, but yeah, that implementation that I had downloaded myself and I had shown you to download is actually the CPython implementation, which is Python built on top of C, the C language essentially. There are other implementations such as IronPython, which uses the .NET framework, and JPython that uses Java virtual machines that you could use if you were interested. But again, these are things that I would not worry about too much right now. So now that we have tackled on how to install your implementation of Python, I want to introduce what is called a distribution to you. This distribution is called Anaconda. Anaconda is a very important distribution, especially if you are looking to use Python in data science and machine learning and AI, which I am assuming is the motivation for many of the people that are actually watching this video, that they actually want to move into data science and they need to learn Python as a foundation towards moving towards data science. And if that is your goal, or in any case, whatever your goal may be, I would recommend that you install Anaconda distribution. Now, do not get confused between Anaconda and Python. Anaconda is Python with in the form of a bundle, and this bundle contains not only the basic Python implementation that I had shown you to download, but it contains a lot of extra libraries and technologies and softwares as well. So, of course, this means that would you need to download both? Of course not. If you downloaded Python, you do not need Anaconda to work on Python. And if you have already downloaded Anaconda, which I will show you how to do it in some time, if you have already downloaded Anaconda, you don't need to download Python separately. So I'll just speak about Anaconda a little briefly. So as I said, it's a distribution. It contains a bundle which includes the basic Python implementation and a lot of technologies and softwares and applications that essentially help us to use Python in specifically managing big data applications and data science related projects. So now I will show you actually how to install Anaconda on your system. It's as simple. It's actually as simple as downloading just this thing. So if I did a quick Google of Anaconda, so the website that I'm looking for is anaconda.com, and I'm looking at products and I'm looking at individual edition. There are other editions as well, like commercial, team edition. These are for companies usually, or for more professional sort of projects. So of course we are looking at the individual edition, and if you selected this page, you would be taken to this particular web page where it will ask you if you want to download. And again, there are options depending on which machine you're using. If you're using a Linux, you would choose one of these two. If you are using Mac OS, you would use one of these two. And since I am a Windows user and I have a 64-bit system, this is the option I would use. So again, it will first download an installer for you. And as you can see, my installer has been downloaded. So upon opening it, it will open up this installation thing. You can just click next on most of these. Again, if you want to specify your destination folder, you can change it here. Mine will be with a default folder in the C drive, and you can leave this unticked. You can change these options much later. So this is how you install Anaconda on Windows, and it's pretty much the same on other systems as well. Now once it's done, I will show you what are some of the things that Anaconda contains that are not there if you installed Python like the way I had shown you earlier, just the bare bones Python implementation. So as you can see here, my installation is actually complete, and now I will open Anaconda and I'll show you how you can actually use this Anaconda. So if I search for Anaconda in my system, I would look for something called Anaconda Navigator to actually get started with this. And when I open that, it should open something like this. So this is what opens when you click on the Anaconda Navigator. And as you can see, there are a bunch of applications. You don't need to worry about what these mean right now. Just understand that this is essentially a bundle of different applications and technologies that come along with just the normal installation of Python that you get when you install Anaconda Navigator. Now that we have actually tackled where we've seen how to install, and I'm hoping and I would recommend definitely that everyone is watching this video installs Anaconda, not just the normal Python installation or implementation. Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that, instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy, and it's not very useful for a beginner. Another way is using a text editor such as the one I have opened right now, which is the Notepad++ text editor. Now it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now, rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most common, one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. Alright, now where it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose any sort of interpreter, or anytime we need to read the script to know that it's a Python script, we need to add a .py. Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, you go, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since my file is already in the folder that I am in my command line, I would just have to enter this command right now. So if I execute this, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print this these two words. And of course, the command line is now waiting for the next command for me. So this is one of the most simple ways or the most rudimentary ways of executing a Python script. Now, another question would be, well, this isn't the most visually appealing or not the easy to read or easy to use way of executing scripts. And I would agree. And that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or in any programming language stands for Integrated Development Environment. It's essentially a software that not only allows us to run scripts, but it allows us to create the scripts. It allows us to debug. It allows us to see outputs. It allows us to see intermediary outputs. It allows us to do a wide variety of tools and tasks. And it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda Navigator, as you can see, the Anaconda Navigator shows me a bunch of technologies and options, and I'm looking for something called the Spider IDE, which is over here. As you can see here, it's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. So this is the Spider IDE in particular, and this is how it looks. Don't worry about the exact details. Just know that on this left-hand pane is our current script that is open out here, and out here we will get the results in this is what we call a console essentially. So now that we have already created our script in Notepad++, and I want to open that script and I want to see how the result of that script would look in an IDE. So let's just open it. So we can browse for our file, and as I had named it test, this is the file over here. I open this, and as you can see out here in the left hand pane, my script has opened and the command that I had given or had written is out over here. Now if I want to run this application, I press this green button, and as you can see, the result of my execution essentially is over here. It's in slightly small font, but as you can see over here, it says hello world. And the next line is essentially it's waiting for me to do another execution of the script, and then it will give me new results. So let's actually give the system new results. So now that I have printed something called hello world, let's change what's written over here. Let's say I will perform basic maths. Alright, and then let's actually perform the basic maths. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called a. Let's store a number 3. Let's create a variable b, store a number 5. Alright, let's create another variable c, which will store the result of what's in a and b, in the addition of a and b. Alright, and let's print the result, or print what's in this variable c, or what's the result of a plus b. I will print a statement saying the result of the addition of 3 and 5 is, alright, and I will put my result over here. As you can see, I should get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I performed 2 print statements, and I've performed a basic expression, some variable assignments. All of these things we will be doing later. This is what I'm essentially trying to show you is that IDEs are a very convenient way of not only creating the scripts but actually seeing the results and then making adjustments as well. We can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the IDLE IDE. It stands for Indicated Development and Learning Environment. So the IDLE IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or Integrated Development and Learning Environment. But of course, since we are using Python, and that's what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I open or when I launch the Jupyter notebook, this is what I get. Now, a very important feature or a feature of notebooks is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. You don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function, this is a separate addition, another separate print function, and for longer programs or larger programs, you'll have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now I want to do what is 5 plus 3. It should give me the result over here, 8. Now the next, another part of your program might be storing 5 and 3 into variables. So I can do this and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables. And I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks, and I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts of different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects, 5 and 10, are being added, and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything, it's simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner, so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b, and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like forNum is equal to something, say the same string hello, this would be an illegal variable name and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num underscore 4 and I said random, some random string, this is perfectly fine. However, if I changed num underscore 4 to num hyphen 4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words in Python. Now Python has a bunch of reserved words. These words essentially are performed, or they are used to perform certain special functions and are used as identifiers for certain special functions in Python that have a special purpose. Like that particular word has a special purpose within the Python programming language, and we cannot use them to name our variables. So a list of them, as you can see over here, some of them are like false, def, if, del, raise, and there are around 33 of them. And sometimes some of these words are taken out. Sometimes there are more words added as Python gets updated. Now let's move on to a concept where we try to really understand what do we mean by storing data inside a variable. Now when I say that we are storing something inside a variable, you get an image or you get an idea in your head that this variable is like a container where we store or we put a particular object inside it. So does this mean that variables have a place in the memory? Are they also an object that is placed in the memory where we can put other objects inside of? Well, I'll show you an example where this idea is kind of disproven, or where I'll show you that the idea of variable is kind of different than what we understand by storing something inside a variable. Now, let's say I'm storing the same object. I will take this object as some random number, let's say 100, and I'm going to store it into two different variables. So I take x is equal to 100 over here, and in the next line I will store 100 in y as well. Now, if variables were objects that we placed in our system, then x and y should have two different IDs. But let's see what happens when I check the ID of x and the ID of y. They should be different in case variables were their own objects. However, as you can see, the ID of x and the ID of y are exactly the same. So, well, obviously we know that two different objects in Python cannot have the same ID. So what does this mean when it comes to the nature of a variable? Well, the fact is that variables are not actually objects in Python. In fact, variables are more like pointers or references to the actual object. So when I said x is equal to 100 and y is equal to 100, what I'm actually telling the system is that there is this variable name called x that I want to refer or point towards the actual object that is in my memory called 100. And I do the same thing with another variable y. So I am not exactly creating a different space in my system for these variables. These variables are more like placeholders or references that point to a particular place in the memory where this object is located. And that is what happens when I do ID of X and ID of Y. It's not giving me the ID of something called X or the ID of something called Y. It's giving me the ID of 100 each time because 100 is stored in X and Y. So as you can see, this is something like a visual representation of what I'm trying to say. And similarly, if I were to, so in this example on the left, as you can see, I've used the value of 50 to explain my point. So as you can see, initially X and Y are pointing towards this value 50 because I have stored 50 and 50 in both X and Y. Now what if I changed the object that is stored in X? Well, that means X is now pointing towards this new object, and I have stored this new object called hello, this string called hello, as you can see here. So now X is pointing to a new object in the system, and it's called hello. And I haven't changed anything with respect to Y, so Y will point towards the same thing. And I can also make the pointer of Y different, or what I'm trying to say is I can store something else in Y. See, I stored this list in Y, 50, 60, and 100. And when I do that, now Y is pointing towards a different object in Python. And X is also pointing towards something else. So what happens to this object 50? Well, now that there's no variable referring to this object 50, it becomes what we call an orphaned object. And we can actually see that when we do the ID of X, now let's go back to my example on the right where I stored X is equal to 100. So as you can see, it gives me some ID represented by this number. Now let's say I stored something different in X, say 200. Now if I do the ID of X, it should give me a different ID because as you can see, the values are different. And this is because this object 200 is what is stored in X, and when I do the ID of X, I'm actually getting the ID of this new object now, 200. So as you can see, variables are, they should be, and they are treated more like references or pointers instead of containers for a particular object. In this video, you will be introduced to the concept of objects in Python. Now, what are objects in Python? Well, all the data that we manipulate or use in our operations in our code are represented as objects or relations between objects. So if you want an example, two numbers that you add in your code, well, both of them are objects, and they're usually numeric type objects. Similarly, if you want to store someone's name or an address of your hometown in your code, you usually store it in a form of text, and that text is also an object, usually a string. Similarly, you might want to create a container of different smaller objects inside them, and that big container is also a type of an object, and one of those containers are called lists. And similarly, we have many different types of objects which we will be covering during the duration of this course. The following pictorial representation gives us a broad classification of different Python data types and objects. As we can see, there are 5 broad classifications: numeric, which contains integers, complex numbers, and floats. We have the dictionary data type. We have the Boolean, which essentially consists of objects that have only 2 valid values, true or false. Then we have sets, and we have sequence data types, such as strings, lists, and tuples. Every object in Python has 3 important properties that kind of define that particular object. They are its identity, its type, and its value. The identity of an object is, it can be considered as a place in the memory or its address in the memory where an object is stored. An object's identity does not change once it has been created. So for example, if I took an example of, say, a string called hello, I can use the ID function, this is how you use the ID function to find out the ID of this object. And it should be, the answer should be in the form of a particular long integer. So as you can see, the ID of hello is this integer 2326476623024. Similarly, all objects in Python have an identity. We have another operation with regarding the identity of an object is the is operator, and the is operator compares the identity of 2 objects. So if 2 objects have the same identity, it should give the answer true, otherwise false. Now the next property of objects is the type. The type of an object is essentially what defines what kind of values and operations that object can have. So for example, A numeric data type in Python, such as an integer, would allow us to do arithmetic operations. And similarly, string object type in Python will allow us to do concatenation operations. Much like its identity, the type of an object cannot be changed as well. Now let's see what's the type of that particular object that I had shown you above. As you can see, it should be string. str stands for string. Similarly, if I did a type for a number, say 50, it should give me int, as you can see. Now the third property of an object in Python is its value. Now the value is the actual data that is contained in the object. It's the thing that we use, that we display, that we can manipulate, and that we can perform operations on. So for example, if I were to talk about this string is hello. So the value of the string is the word or the sequence of letters that spell out hello. And similarly, this particular object is a numeric object with the value 50. Let's see, in this pictorial representation, I have shown you that you can assume this dashed blue area as the memory of the system. Now within this memory, we have objects created called 50 and hello, and this list containing smaller objects called cat, pen, and 40. Now, what I'm trying to show you here is each of these objects have a type, an ID, and a value. And let's see what they are. If I wanted to see, as we had already seen the type of 50, now let's find the ID of 50. As you can see, we get this unique ID for the object 50, which is obviously not the same as the ID of the object hello above. And the value of this object is the value of 50 itself. So that was a brief introduction into objects in Python. In this video, we will cover the topics of numeric object types and type conversions in Python. So let's get started. Numeric object types in Python are a broad classification of objects. Plenty of common real-life applications that we associate with numerals, such as arithmetic operations and calculus, are done in Python using numeric object data types. There are three main types of numerals or numeric data types in Python. They are integers, float, and complex. Integers, as the name suggests, represent all integer values in Python. These can be such as 100, -3, to 305, and so on. Floats are used to represent numerals that contain decimal points, such as 100.3, 3.9, 4.8, -6.8, and so on. Then there is the complex object type, which is used to represent complex numbers in Python. And this is an example of a complex number, 3 plus 7j. This is a complex number 3 plus 7j, where the real component is 3 and the imaginary component is 7. All complex numbers have a real and an imaginary component, and this is how we denote them. Now it's important to note that this j is a very common symbol in maths and engineering used to denote the imaginary portion of a complex number. And it's the same in Python as well. So moving on, let's talk about type conversion in Python. Type conversion refers to the conversion of an object from one data type to another, for example from string to an integer. And there are different types of conversions, and let's go through some of them. First of all, let's consider the conversion of something to an integer, and more specifically, let's consider the example where we convert a string to an integer. So let's consider my example string to be something called 145, and I'm storing this within a string for a reason, because I want to convert a string to an integer. So as you can see, I have stored this 145 within a variable x, and if I were to confirm that it is actually an integer, I can use the type function and see that it is actually an integer, str. Now let's convert this into an integer using the int function. So how would we use it is simply passing the int, by passing the variable that we want to convert into the int function. And as you can see, this is what I've done over here, but before this I will also store it into another variable. Alright, now let's see what's in y. Well, y gives us 145, but are we sure that it's an int? We can just check it by using the type function. And as you can see, the type gives us the answer int. That means that we've converted the string to an int. Interestingly, we can convert something and also specify what base we have to treat the number as. By default, when we pass something in the int function, the program or Python will treat whatever we have passed within the string as something in base of decimal. But what if we were to pass something that is, well, not in a decimal? Well, we could do it like this. Now let's store y, and in y, let's do this, and I will show you what this means. X, and I will give a comma and 8. What this tells Python is, well, I want to convert the string in X into an integer, but I want to treat whatever is in X as a number of base 8. So 145 is actually 145 in the base 8. Now when we see what's in Y, we get 101, which is different to 145 because, well, 101 is actually the decimal equivalent of 145 in the base 8. Similarly, if we were to give it in the base 2, we would just replace 8 with 2 over here. Now next, let's talk about converting something to a float. Now as we know, float is just simply something that has a decimal point. So let's convert an integer into a float. How would we do that? Simply by using the float function. So if I gave 120 and I pass this integer through the float function, I should get 120.0. These two are not the same, though they may mean the same things to us, but for Python, 120 is an integer and 120.0 is a different object, which is a float. And this is how we convert something to a float. Now what if we wanted to convert an integer to a string? Well, we can use the str function. We can also use the hex and the oct function if we want to convert a particular number to a hexadecimal or an octal string respectively. Let's look at all three examples. Say I have a number 688 and I want to convert this into a string. I just use the str function around this. So as we know, just to confirm, let's see what the type of 688 is. This should be an int, as we can see. But let's say we convert it into a string, 688, and let's store it into some variable. Let's call it a. Alright, now let's see what's in a. It gives us 688 in the form of a string, but we can confirm by checking the type of a. It is an str, so it is a string. Similarly, we can use hex if we wanted to convert an integer into its hexadecimal equivalent as an output of a string. As you can see, this sort of complicated thing is actually telling us that we have converted 688 in terms of hexadecimals. Now, how do we read this output? This 0 should not be treated as anything. It's more like an identifier, which says that the letter after this first 0 is the base of this whole number. So it's saying that X stands for hexadecimal. So it's saying that 2B0 is to be treated as a hexadecimal number. And if you did basic maths, you would find that the decimal equivalent of 2B0 is 688. Similarly, if I did oct, if I use the oct function for 688, it will give me the result, something like this. So again, how to read this? The first 0 is to be treated as an identifier and not part of the number. What it's saying is the letter after the first or after this 0 is the base of the number following these two characters. So as you can see, what's this saying is that this whole number is an oct represented by this letter O, and the number itself that we are dealing with is 1260. And 1260 in octal system is the equivalent of 688 in the decimal system. So this is how we've converted an integer into a hexadecimal or an octal string. Now what if we wanted to convert two numeric objects into a complex data object? Well, for that we can use the complex function, as you can see here. If I passed complex 5 and say something like 3.1, let's see what this gives us. As you can see, it gives us a complex object where our real part is 5 and our imaginary part is 3.1. So what this does is essentially you pass two numbers. The first one is the real component and the second is the imaginary component. It combines to give you a complex number, as you can see here. Now let's look at some other type conversions. The next type we will be talking about is converting something to a tuple or a set or a list. So what if I wanted to convert a string into a tuple? I will use the tuple function, and as you can see over here. So let's say I have a string called random. Let's call it random. Alright. Now if I want to convert this to a tuple, I will use the tuple function, as you can see over here. The output will give me tuples where each individual component of this tuple are the individual components or the individual characters of my string random. Similarly, if I wanted to convert the string to a list, I would use the list function. And this will give me a list of the individual characters of the word or the string random. And I could do the same thing with the set function to create a set of individual characters of the string random, as you can see here. So yeah, these were some of the basic Python type conversions that I have shown you. As we learn about more complex data types and different object types in Python, we will learn different type conversions and functions associated with them. In this video, you will be introduced to the concept of strings. Strings are an object type in Python used to store textual data. This textual data could be something like, for example, someone's name. It could be an address of a place, or it could be something like a word or a sentence. Now, strings in Python are an object type that is actually a subtype of a broader classification of objects called sequences. Sequences are objects in Python which contain components placed one after the other, where each component is given what we call an index, a numeric index. This numeric index identifies the component in the sequence and is positioned within the sequence. Now, since Python is a zero index based language, the first object of any sequence is always index 0. The second is index 1, the third is index 2, and so on. Now let's move on to defining strings. How do we define them? Well, strings are defined using what we call delimiters, and delimiters occur in pairs, an opening and a closing delimiter. In Python, these delimiters are pairs of single or double quotes. So for example, if I were to use single quotes to define a string, I would do it like this. This is a string. As you can see, this is a string is printed over here. This is delimited using single quotes. Similarly, if I were to define a string using double quotes, it's as simple as doing this. This is also a, as you can see. Now a valid question arises. What if I wanted to include a single quote within my string? Well, if I tried to, let's see what happens if I try to print a statement with a single quote naturally inside it. So say I'm saying it's my birthday. Alright, let's see what happens if I try to print this statement. It says invalid syntax, and this is because, as I had mentioned, in Python single quotes and double quotes are delimiters, so they have a special function in Python, and we cannot simply just use them within a string because Python will treat them specially for a special purpose. So what Python will do is it will pair this and this delimiters or single quotes and say, okay, this looks like a string to me, and it's not going to understand the rest of this, and then it will find a random single quote and it won't find its pair, and it will basically throw us an error because of this. So one way or one workaround to introduce single quotes into a string is simply to delimit our string itself using the other type of delimiter or double quotes. So if I want to include a single quote, I will close my string using double quotes. So if I did this instead of what I had done earlier, this is a perfectly valid and legal way of defining my string. And I would do the opposite if I had to introduce, say, double quotes within my string. I would use single quotes to close it. So if I were to write a speech statement, she said, I am hungry. Alright, I want these two double quotes to essentially show that this is a speech, and I'm going to close the string using single quotes, and this is a valid way of doing it. As you can see, my string has these two double quotes. Now, I had mentioned that strings are sequences. Well, let's describe how are they sequences. So first of all sequences in Python are essentially a sequence of smaller objects that form the sequence, right? So let's try to understand like how are strings to be treated as sequences. Some sequences that we will learn later are like lists or tuples. And in all sequences, we can retrieve any particular object or component in that sequence using its index. And how do we use indexes in Python? Well, we enclose a numeric index within square brackets. Now let's see what I'm trying to talk about by this example. Now say I'm storing a particular string called, say, random within. Now my variable name here is test, and I'm storing the string random within it. Alright? And this is a way of retrieving a particular index from test. I write the variable name, and then next to it I put the square brackets. Now I'm supposed to put a numeral within the square brackets to tell Python like what particular index I'm looking for. So let's try 0. Now, as I said, Python is 0 index based language. So the 0 index essentially means the first part of, or the first component of a sequence. So let's see what happens when I ask Python to retrieve the first part of what is stored in test. It gives me the string R. In fact, it's just one character R, and it's a string. So as you can see, it has given me the first character of the string random, which is R. So what this shows is that this string random is essentially a collection or a sequence of one character strings. So random is essentially a collection of the string R, the string A, the string N, and so on together combined to form the whole string that we call random. Similarly, if I wanted the character at the third position of this thing, I would use, well, since it's the third position and since we're working in Python, I would use the index 2, and it should give me the letter N. As you can see, it's given me the letter N. So this is how we can show that strings are also sequences in Python. Well, now let's move on to certain string operations and functions that we can perform. Well, as you have seen already, that we can retrieve any particular character within a string using numeric indexes. Well, what if we wanted to know what index is a particular character at? And we can do it like this. We use the index function. So let's say my test, and I want to know where or what position the character D is in my string random. So this is how I would use the index function. Index, and within the index, say I'm looking for the character D, and now it should give me the answer 0, 1, 2. It should give me the answer 3. So if I execute this, it gives me the index 3. So this is the index function that we can use for our strings. Now, what if we want to say slice a string into a smaller part? We want to slice it, and we want to retrieve only that particular slice. Well, here is an example. Say I'm going to use the same string called random, and it's stored in test, right? So the way of doing this is like this. Now let's just see what this does first. As you can see, it's given me A and D, and if I went to my string random, A and D is this particular slice. Now let's try to understand what I have done by entering 1:4. Well, what this has done is it's retrieved a slice from the first position, the first index, which is the character A, up until the fourth position, which is the character O, but it has not included O. So it's very important when I index like this, every time I put something to the right of this colon, I am not including this itself. Alright? So it's essentially when I say 1:4, what I'm telling Python is give me the first, the second, and the third character, but not the fourth one. So it's given me A, N, and D. And this is how we do a slicing operation in Python. Similarly, if I were to say slice from the first, if I wanted only the first and the second character, this is what I would do. If I wanted the first and the second character, I would do 1, 2, 3. So this way it tells Python that I want the first, I want the second, but not the third of. So as you can see, I get A and N. Now, so this is a basic slicing. What if I wanted the portion of a string from a particular point all the way to the right or all the way to the left? Well, let's consider the example of where I want the portion of the string random from the, say, fourth character until the left. Well, the way I would do this is test. Now, since I want it all the way to the left, I don't enter any index to the left of my colon sign. And since I want everything to the left of the fourth character, I enter 4 here. So as you can see, it gives me A, R, A, and D, which is everything from the fourth character of my string random to the left. Similarly, if I wanted something to the right of it, I would just do it like this. I would enter some index here, and I would leave the portion to the right of the colon blank. So this will give me everything, including the third character, since this is how we treat the indexing in Python, everything including the third character all the way to the right. So this is DOM, as you can see. Now another perfectly valid slicing is, say I want to slice or take out different characters from the string, but I want to skip certain characters. Like I want this one, then I want to skip one, and I want to take the next one, and then I want to skip one. Well, in that case, we have to introduce a step. So one way of doing this is, now how do we read this? So as you can see, I've written 0:6:2. So what this is telling Python is, I want every character from my string test, starting from the 0th character up until the 6th, but not including the 6th, after skipping or taking 2 at a time. Taking 2 at a time can also be assumed as skipping 1 at each step, or skipping 1 character at each step. So what this will do is, it will go to random, it will take the 0th one, it will take R, and then it will skip the next one. So it will not consider A, and then it will pick N, and then it will not consider D, and then it will consider O, up until the 6th character, whichever that may be. And if you see the output, it gives us R, N, O, which is exactly what we wanted. We wanted R, we wanted N, we wanted O, where we skipped A and D, or we skipped every second character essentially. So this is a way of slicing strings while also skipping certain characters, or skipping characters in steps. Now Python is also there's another interesting technique that we can use in Python to where we can start retrieving characters from the rightmost side of a sequence or a string. We can use negative indexes. So if I were to, for example, show you, let's see what this gives me. Test, what is a -1th index? It gives me the character M. Now remember, a string is random, so -1 gave us the last character of the string random, which was M. So this is a way of using negative indexes. And similarly, if I used test -2, it would give me the second last character, which should be the character O, as you can see here. Now there are some other important functions that you may use in Python. So for that, let's create another string. Let's call it upper, lower. Alright. Now I'm storing it again in the same variable test. Let's see what happens when I use the upper function and what happens when I use the lower function. Now I'm going to use the lower function for this. So these two functions will respectively give us the result, or give us our string in uppercase and lowercase respectively. So as you can see, the upper function created the first string in full uppercase, and the second one created this string in full lowercase. Now another important, and probably one of the most important methods that we use for strings, especially when it comes to data science, is the split function. So let's see what I mean by the split function. Let me create another string. Let's call it hello world. Alright. And I'm going to use a split function, and I'm going to see what happens when I use this function essentially. So what I'm doing in these three lines is, I'm creating the string hello world, I am storing it in test, and then I am using the split function on the test, and whatever result I get, I'm storing another variable called sliced, and then I'm just going to show you what is in sliced. As you can see, what's happened to the string hello world is that I have broken it into its components, or its component words, if that makes any sense, into hello and world, and I've stored both of these into what we call a list. Now you might ask, well, how does Python know that it has to separate at a blank space? Well, the split function by default will break up a string at its blank spaces. But if we wanted, we could break it up using or at every comma. So for example, if I wrote hello world using comma, and if I put a comma inside over here, and now if I try to execute this, like for example, I'm going to look for commas in the string, and then I'm going to try to split it. As you can see, there's no splitting happening. I have one list with my original string itself because it's not found a comma. What if I introduced a comma over here? Now let's see what happens. As you can see, the splitting has happened. It's found this comma and it's caused a split between hello and world. Similarly, in my string, if I put a comma again and I put something else, it should give me the split over there again. So we can define our split using whatever we put in between these circle brackets after the split function. It's just important to note that by default, if in case we do not enter anything, over here, it will use blank spaces to do the splitting. Another very important operation and very common operation in strings is what we call concatenation. So if I have two strings first and say another string second, and I want to join these together, well, the operator I would use to do this is called the plus symbol. This is the concatenating operator when it comes to strings. So what is the result of this? Let's see. Let's print this out. Let's print this whole thing and let's see what is the result. As you can see, what this has done is it has combined the first string first and the string second into one string called first second. So this is the concatenation operator. Now finally, the last topic in this lesson is the topic of escape sequences. Now escape sequences are special commands that tell Python to either suppress special meaning of some character or symbol in a string, or give some special meaning to an otherwise ordinary character in a string. So let's look at the first example. Now remember earlier in this video where I was telling you like what is the way of writing, or how do we introduce single quotes or double quotes into a string, and I had told you the trick. If I want to use a single quote in my string, I just close it using double quotes, or if I want to use a double quote, I close it using single. Well, another way of doing this is using what we call an escape sequence. And an escape sequence in Python is the backslash character. Alright, so let's see what happens when I use the backslash character where I want to introduce my single quote. So if I use my previous example where I wanted to introduce a single quote and say I'm going to close it using single quotes as well. So I'm going to go back to my error example, so as to speak. Now this would throw me an error, right? As you can see, it has thrown me an error. So what if I used the escape sequence that I mentioned? The escape sequence is just backslash character. Now this is the point of the string where I want my single quote. So I introduce a backslash. Now I have my single quote and I continue writing the rest of my statement. Let's close the string. Now will this work? As you can see, this has worked. So what this has done is this backslash character has told Python to not treat this special character or the single quote, to not treat it specially and let it be as a part of the string. So as you can see, that's what's happened here. Now the next case, or the other use case of escape sequences, is when we want to give a particular character that is otherwise just ordinary some special meaning. So let's take the example of the character T and the character N. We use the character T to introduce tab space, and we use the character N to introduce what we call line break. Well, let's see by an example. So normally the character T has no special function. So the character T within a string will just be outputted as the character T itself. However, as you can see here, I'm going to introduce a backslash before this character T. Let's see what it does. It introduces this thing that we call a tab space, which is a larger than normal space. Similarly, if I were to use the backslash n combination, this would introduce what we call a line break. And if you were to see the output of this, you can see at the point of the string where I have this combination of backslash n, a line break has occurred. So there are plenty of other escape sequences that you may choose to learn, and these are just two of the probably the most common ones that I used. So yeah, this was an introduction into strings in Python. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered, arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? Lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains 3 objects, 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if 2 lists contain the exact same elements, if the elements are placed in a different order, the 2 lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3. The same elements but in different order. I will use the is function to check whether these two lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have two lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are making or as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say increase or we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists are, they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list. And I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I wanted to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is, I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider every second element essentially. So what it will do is it will go here, and then it will skip one, and then go here, and then skip one. And that's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. Alright. So let's see what happens when I take every second element. It should give me, it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say A minus 1, it's essentially looking at the last element of the list. So it gives me the 6th or the last element, which is the object 6. If I did A minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax, : and we give a -1. What this tells the system is, I want the list A but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be two similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this. And I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication, or a replication function, where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's the 3 strings, eggs, apples, and carrots, and I have 5 int objects, 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with, say, mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first 3 elements. I want to replace mango, I want to replace apple and carrot. So what I will do is, I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with 3 different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my 3 elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, 3 elements with only 1 or 2 elements, that is also possible. So now if I want to replace the first 3 elements, kiwi, orange, and sponge, with just 1 element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, 3 elements have been replaced with 1 wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with 3 different elements, an obvious way would be just consider that element's index and then put whatever objects you want. Say I want to add, instead of wine, I want to add beer, I want to add ball, and say club. Yeah, well, let's see what happens. Now if I say B, check what's inside my, you can see my elements have been added, but they seem to have been added as is. I had entered a list over here, and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace one, if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine, and I had 1, 2, 3, 4, and 5. Now if I do this, B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace, it will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have I've removed wine, and in place of it I've put beer, ball and club, but these three are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2 and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append 3 different objects. I want to append 5, 6 and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list, and this is not what I wanted. I wanted 5, 6 and 7 to be individually placed, and we do have a way of doing that, and the way to do that is the extend function. That is what I'll show you next. Now if I want to extend, say, the original list by 3 different elements, 8, 9, 10, when I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parenthesis you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, alright, this number, if I want 8 itself removed, what I will do is put the value 8 here and it will remove it from my list. So if I check my list A, as you can see, the value 8 it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list, but unlike remove, the pop function actually outputs a value and that value is what we have popped out of the list. So by default it will pop out the rightmost value of a list, or rightmost element of a list, and in this case that element is 10, so it should give me 10. But of course if we want to pop out any particular object, in this case we do not give that particular object, we give its index. So now say if I want to remove this list object from my bigger list, as I can see it's in index 0, 1, 2, 3, 4th, it's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in 2 key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2 and 3. And the next very important property that is different, or that differentiates tuples from lists, is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list, or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So you use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to, or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I will be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3 and 4 tuple into t, let's unpack it into another tuple. Let's call this, let's put these elements into this tuple, and I put this into t. Alright, now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in b, it gives me the value 2. If I see what's in 3, it gives me value 3, and d gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into t, and then put that tuple t into this tuple a, b, and c, d. So what has happened essentially is the element a has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto a, 2 has been unpacked onto b, 3 has been unpacked onto c, 4 has been unpacked onto d. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to a, 2 to b, 3 to c, 4 to d. I have matched these two tuples together like this, and this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements on this tuple and the elements on this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright? In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did x, comma y, comma z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in x, it is actually 5. If I see what's the value in y, it is 6. If I see what is the value of x and z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. So yeah, in this video we will cover concepts surrounding dictionaries. Dictionaries are another type of composite data type in Python that are also a collection of objects, much like tuples and lists. And like lists, they are also mutable, dynamic, and can be nested. However, a key difference and property of dictionaries is that they are unordered. Items in dictionaries are paired using keys, unlike in lists and tuples where the objects are assigned numerical indexes. To define a dictionary, we use curly braces. Each key value pair in this dictionary in a dictionary is separated using commas, and the key and values themselves in a pair are separated using a colon. Let's look at an example. This is a dictionary where I have 3 key value pairs. As you can see, they have been separated by colons, and each pair themselves are separated by commas, and these are enclosed in curly braces to define the whole dictionary. In this example, these are the keys: banana, apple, and grape, and their respective values are yellow, red, and green. So this is very important, that in this particular data type, we have what we call a key, and that key is assigned a value, and we can have multiple such pairings, and we have 3 such pairs in this particular example. Another example, or another type of way to define a dictionary is using the dict function. This is how we use it. As you can see, I have inputted 2 value or 2 object tuples. This is a tuple, this is a tuple, and this is a tuple. And when I use it in a dict function, when I place it within a list, what Python will do is it will consider the first element of each tuple as a key and the second element of each tuple as its respective value. Now if I check what's in D, as you can see, the key banana has a value yellow, the key apple has a value red, the key grape has a value green. So this is another way of defining dictionaries. An important note over here is that the objects that we use for keys have to be of an immutable data type. So we cannot use, for example, lists as an example of keys, but we can use, say, integers or strings for our dictionary keys. Also, keys have to be unique when it comes to a dictionary. You cannot have 2 different keys with, or should I say, the same key having 2 different values. You can have only one key, and that one key will have a unique value assigned to it. Duplicate keys are not allowed. However, when we speak about values, we have no such restrictions. You can have a mutable or an immutable data type as a value in a dictionary, and you can have duplicates as well. So, if I created a dictionary with a key, say, banana, and if I associated with it a value green, I cannot create another key banana and associate a value yellow. Let's see what happens when I actually do this. If you actually see, what has happened here is Python has considered the second case. So it first looks at the first pair, it goes, okay, so my dictionary has a key banana with a value green. But right after it, it sees another key banana with a value yellow. So it overwrites my first key banana with the second key, and it overwrites the first value green with the second value. And we essentially get one key banana with the second value yellow. So obviously, this is Python does this to avoid duplicacies. However, if I created a dictionary with a key banana again, if I gave it a value yellow or say green, if I created another key, and if I gave this also a value green, this is perfectly fine, and this will nothing special will happen in this case because values do not have to follow such rules. Let's see certain dictionary operations and functions now. So let's bring back our original dictionary, which we had created earlier with the 3 pairs. Alright. So what if I wanted to, we can use keys to essentially do these operations and functions. Let's see what happens when so much like how we use indexes in example of sequences, we use keys when it comes to dictionary. So let's see what happens when we use a key over here. So as we know, banana is a key in this dictionary. Let's see what happens when we give this command. It actually gives the value associated with that key, which is yellow. What if we wanted to change a particular value associated to a particular key? I would do this. I would give the key and assign it the value that I want to change it with. Alright. Now if I check my dictionary, you can see the key banana no more has yellow value but the value gold. What if I wanted to add a new pair? A new key with a new value completely. I would do it pretty much the same way as I did in the previous step. I would essentially write my new key, whatever I wanted. Say if I wanted a new key called watermelon, I would assign it a value red. And now if I check my dictionary, at the end of the dictionary, you will see that my new key value pair has been added, watermelon red, as you can see over here. Now what if I wanted to remove a key value pair from my dictionary? I can use the delete function, which is called by using this, the del function. Now how do I do it? Say if I want to remove the key value apple and red. So all I have to do is do del, and within square brackets I have to only mention the key. I don't even need to mention the value, just the key. So you can probably draw parallels in how we use indexes when it comes to lists and tuples and even strings, and how we use keys when it comes to dictionaries. They are quite similar. So if I did this, and if I I think red is actually not a key. As you can see, red is a value. My key is apple actually. It's not red, it's apple, as you can see. Now if I see my dictionary, the key apple and its value red has been removed. So these are some of the operations that we can do for dictionaries using keys. What if we wanted to use certain inbuilt functions that are associated with dictionaries? Well, some of the examples are as follows. There is a get function. When we use the get function, all we have to do is enter a key inside the parenthesis, and it will get the value associated with that key. So if I gave the key grape, let's see what value is associated with it. As you can see, it's green. There is also a that returns the key and value pairs in our dictionary as a list of two object tuples, where the first object is the key and the second object is a tuple. So let's see what it does. As you can see, it gave me a list, and in this list the objects inside the list are two object tuples, where the first object is always the key and the second is the value, and it's the same for each of the tuples. So this is what items function does. Let's see what the next function is keys. Let's see what the keys function does. As you can see, it returns a list of all the unique keys within our list, within our dictionary. Similarly, there is a function for values as well, and as you can see, it returns all of the different values that are present in our dictionary in the form of a list. Also, it's important to note that if we have a particular value that has occurred multiple times in a dictionary, it will appear as many times it has occurred in the dictionary or appeared in the dictionary in our list over here when we use the value function. So if, say, a particular value, say I had another key where its value was green again, so I would have the value green appear in this list once more, essentially. Our next function is pop item. What this does is, much like the pop function in lists, it gives us the last entered key value pair that is present in our dictionary. So the last entered pair was watermelon, key watermelon with the value red, and that's what has popped out when we give this function. Another important function associated with dictionaries is the update function. And the update function is a very neat function that is used to merge two dictionaries together. So say if I had a dictionary, let's say I'm creating a dictionary using the dict function where I have, say, some key called kiwi. So as I had mentioned, I will use two object tuples in this case, and let's say I give this also a value green. All right, and another pair would be, say, mango, and let's give it a value yellow. All right, so this is another dictionary that we have created. As you can see over here, we have created a dictionary with a key called kiwi with value green and another key mango with the value yellow, and I already have a dictionary D with these values. All right, now if I want to merge these two dictionaries, I can use the update function. What I do is, say if I want to merge D with X or X with D, only the ordering will change, and that doesn't really matter when it comes to dictionaries. So if I want to merge D with X, I use D update, and then inside it I put my target dictionary. Now when I check what's in D, I have the dictionary X and its key value pairs merged inside my original dictionary D. As you can see, I have my original ones here and I have the merged ones over here. So this was the update function. In this brief video, I will explain what we call the type hierarchy or the standard type hierarchy in Python. It's also known as the data model in Python, and it probably has other names. So essentially what we do or what we speak about in this is how the different types that we use in Python are categorized and classified and what are their subtypes. So it's important to note before we continue further that in future versions of Python, there might be new types that are introduced, or the existing ones may be modified. But it's safe to say that what I will speak about in this video will still form the core of what we call Python standard type hierarchy. So let's begin. So the first type is the none type. It's accessed through the built-in name none. Its truth value is false. It's essentially used to denote functions, or it's returned as the value for functions that don't really return anything. So if you have an expression or a function that returns no particular value, you actually get a data type called none. That is how Python interprets it. Then there is the ellipses. Ellipses is something that you might encounter later. It is accessed through the built-in name ellipses. It is used to indicate the presence of this particular syntax, this particular symbol or expression or syntax in a slice. Its truth value is true. Again, don't worry too much about ellipses right now. Next is numbers. And numbers is something that we are very familiar with. We've worked with numbers a lot. They are an immutable type. They are created through numeric literals, and they are the outputs of arithmetic expressions and built-in arithmetic functions. Its subtypes are integers, floating point numbers, and complex numbers. Within integers, you have plain integers that represent numbers in the range this number and this number. So this number is basically the largest positive value that you can represent using 32-bit notation in 2's complement, and this is the equivalent for the negative side. Long integers, on the other hand, are used to represent numbers in an unlimited range that is only subject to the available memory of your system. So these are two types of integers, and as we know, floating point numbers represent machine level double precision floating point numbers, or numbers with a decimal point and a component after that. Complex numbers are numbers that contain a floating point number that represents a real part and a floating point number that represents an imaginary part. So these are the types of numbers. Then we have sequences. Sequences are finite ordered sets indexed by natural numbers. So each element in a sequence has an index, and that index is a natural number. The different types of sequences are based on the mutability, whether the objects can be changed or not, is essentially what we mean by mutability, right? Once we create an object, whether we can modify it or not. That is how we differentiate different types of sequences. So there are mutable and there are immutable types. The different types of immutable ones are strings. We know what strings are. They are sequences that contain characters. Unicode is the other immutable sequence, and then there are tuples. Tuples are a collection of arbitrary Python objects, and unicodes are sequences that contain Unicode characters. Then we have mutable sequences, and there is only one. Currently, there is only one built-in mutable sequence in Python, and that is lists. Lists are also, again, collection of arbitrary Python objects. Finally, we have, well, not finally, but next we have mappings, and mappings are, again, sets of objects, but these objects are now indexed using arbitrary index sets. You know, the difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings, they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python, there is only one built-in standard mapping type, that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So these, so what I have mentioned until now are probably the most common data types that we encounter, or that we have encountered now. So next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that we that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime and as we will during the course of this tutorial, during the course of this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. So this was a very brief introduction or explanation into Python type hierarchy. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division or the single and the double backslash is this. Say I did 9 divided by 2. Using a single backslash, it should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power or something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. So as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true and false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. If I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, Now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did x is say equal to 2 and now y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false. As you can see, since x is 2 and y is 3. As you can see, x and y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if x and y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because x is not equal to y in this case. The next one is greater than. So if I did x greater than y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did x lesser than y, I should get true over here, as you can see. Well, there's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say x is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright. So now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11. As you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b, or 6 by 2, and it will assign that back to a. So my value in a should be 3. As you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see, if I did a is equal to 7 now, and then b is equal to 3. Now, if I did a double backslash equal to b, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. say a is equal to say 5 now, b is equal to 2. Now if I do a percentage symbol equal to 2, I mean b, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in a. As you can see, it did a divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide a by b and then give me the remainder and then put that remainder back in a. And as you can see that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have a is equal to say 5, b is equal to 2, and I want to raise a by, if I want to raise the value of a by the value of b and then store that back in a, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If a is equal to 1001 and b is equal to 1000 plus 1, alright? If I did a is equal to 2, this is an equality check. Are they the same values? True. Now if I say a is b, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of a. The ID of a gives us some value like this, and the ID of b gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. And the is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether, now say 2 in a. So is 2 in a? If it is, it will give me true, as you can see. Is 5 in a? It should give me false because 5 is not in a. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, I will be speaking about what precedence or what importance each operator has when you use multiple of them in a particular statement or a command. This is what we call operator precedence. So of course there's confusion when we don't know which operator has precedence over the other. And in Python, there is a strict precedence that is followed in such scenarios. So this table gives us the precedence. So as we can see, the operators at the top are at the lowest precedence. And as we go down, we get operators with higher precedence over the ones above them. So of the operators that we have seen, the OR operator, the AND, and the NOT have the lowest precedence. So OR, AND, and NOT, and then we have comparisons and identity operators such as the equal to sign, the exclamation equal to sign. So these operators come at the next level. Then you have addition and subtraction followed by multiplication, division, modulus, and floor division. And finally, the highest precedence of all the operators that we have seen till now is the exponentiation or the double asterisk. So let's see a couple of examples that explain this point a little more. So as we can see in this line, we have 20 plus, then there's a 5 and asterisk 3 minus 25. And we want to know like, okay, what is the precedence in this case? So as we know, we have the plus sign, we have a minus sign, and we have the asterisk sign. So we have addition, subtraction, and multiplication. So which one will take precedence over the other? Well, let's refer to this table. As you can see, the addition and subtraction have lesser precedence over multiplication. So this multiplication will happen first. So we actually do 5 into 3 first. We get 15. After that, we do plus and minus. So we get 5 into 3, 15. Then we add it, or we can subtract it with 25. That does not matter. So we do 5 into 3, 15. And then we do 20 plus 15, which is 35 minus 25. So we should get an answer 10. As you can see, we do get the answer 10. Another example would be where we have this plus symbol, we have a double asterisk which shows exponentiation and a subtraction and a division. So again, as we know, exponentiation has the highest precedence. So in this whole operation or this whole expression, we first do the operation associated with the exponential. So we do 5 to the power 2 or 5 exponentiated by the power 2. So we have 5 to the power 2, which is 25. Now we look at, okay, once we have that, we still have a addition and we still have a subtraction and we still have a division symbol. And as we know, division takes precedence over addition and subtraction over here. So once we do this, we finally move on to this step where we do the division of 6 divided by 2, where we get 3. So we have 25 from this, 5 to the power 2, which is 25, and we have 3 over here. So now we do 20 plus 25, which is 45, minus 3, which is 42. And then as you can see, that is the answer over here. Let's look at the precedences when it comes to certain comparisons or the logical operations or the comparison operations, so as to speak. So I've created a variable called season with the string summer. I've created the variable age with the value with the string 10. So you don't need to put it in a string. So I have the int object 10. And I have the color, a variable called color with the string pink. Now I'm going to see in this line, I'm going to do an if and else statement. So if you don't know what an if and else statement is, just follow along with me. So what this does is, if this condition is met, I will print this statement. Otherwise, else, I will print this statement. Now what is this first condition? It is saying season equal to summer, whether this variable is equal to the string value, or as we know about the OR operation, age is equal to this and color is equal to pink. So as we can see in our comparisons and our logical operations, the precedence for OR and NOT is OR is the lowest precedence, AND is above that, and then NOT is above that. In this we have the OR and we have the AND. So of course the first check is the AND function. So it's going to check whether this whole condition and this condition are it's going to do that operation. So it's going to do this and this. So is color pink? Color is indeed pink. Okay, so this part is true. Now let's see if this part is true as well. Now once we're going to check whether this is true or not, what we need to see is this condition itself has an OR statement. So the first part of it is saying, is season summer? Season is indeed summer, as you can see here. Next part is saying, is age greater than 0? But this does not matter, since the OR function just needs one of the operands to be true, and in this case this is true. In this case it is also true. So this whole statement is true as well. So once we have this statement as true and then this statement as true, we finally move on to, we come back to this AND statement and we say, since both the operations, or both the operands I mean, are true, the resultant of this AND should also be true. And since this is true, this whole condition, we actually move into this section of our if-else condition, where we say, okay, we can do this statement, this print statement, and we do not have to print this particular thing. So our result should be the printing of this string OK. And as you can see, the OK string is actually what is printed over here. So this is an example on operator precedence. Of course, it always helps to, try to fiddle around on your own, create random expressions out of the top of your head and see how exactly Python is evaluating that, and try to understand and break it down on your own. And this is probably the best practice you can do to understand operator precedence. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3. It can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with the radius 3, all I would have to do is use the formula 2 pi r, and to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, so let's see what happens when we call the math function, math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be smaller symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of INF or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus and minus INF, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation, the factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or and it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass maths.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil, as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the largest, it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12, the smallest integer that is greater than minus 12.3, and this should give you 12, as you can minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component, so only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It shall give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So mathematically what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, our GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, which is this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function, and let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of minus 693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is the details are not important. So this will I'm using the math.exponential function over here, as you can see, and for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element, and in 10 years this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of again functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So basic log function would be written like this: math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2. And this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is again I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the math? The square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this, and for arc tan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details you don't have to know the details. You should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be a cos h. So this concludes our video on the math module in Python and some of the math functions surrounding this. In this video, we will learn about conditional statements, and we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if followed by an expression, as you can see from this pictorial. There's an if statement, there is a expression, there is this block of code which, if you can actually see, is slightly indented to the rest of the code, and then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if this statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. Let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this the result, which is this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consists of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this if this condition is met? Well, this is where indentation comes into play. And as you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now it's very important to understand that this is how indentation is used in Python. In other languages we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code, or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for, but it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements, and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here, which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement. which is an interesting thing and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally, I have one small topic that I would like to share with you is the conditional expressions or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement, and then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable x, and this what value I'm assigning to x depends on if this condition is true or false. So as you can see, the condition says is age 18 greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to x. And as you can see, if I execute this and check what is an x, you can see adult is indeed an x. So this is a very neat, a very readable, and a very it's a better looking way to perform simple else simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, if I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's like a way to create a placeholder where maybe in the future I might write some sort of a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. So yeah, this was a basic or an introduction into conditional statements and the control structure of if and else statements in Python.
In this video, we will be doing a small exercise on if statements. Just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is, it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed is equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if else statements are if else statements within if else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0 stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block, else we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true, and finally I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are 2 sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if else statement block. Now what this block is checking is whether the entered number is an even number or not. Now as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number, and that means when we divide by 2, we should get the remainder 1, as you can see here, and we get printed your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered, and the code is telling me that my number is indeed odd. Let's look at some other, what if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20, and my number is even, and the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is, this condition itself is not met, and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1, and we execute this block, which says our number is odd, as you can see here. So this was a brief recap into the if statement and if-else statements, nested if-else statements. We also saw an exercise where we used nested if-else statements. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false, and if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process, and it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop, and then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n, and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times, and each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0, and I print this statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now, this while statement, now it might look confusing. Now it says while A. Now, what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally, we have another statement within this block called the pop statement, where we're popping the elements of A. Now, as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. And again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1, and as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list, and that is why while A returned me a false, and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements, and we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them, and it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5, and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B, and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops, and this is completely executed, and only then do I go back to this first one, and then I come back and do all of this again. Then I go back to this one, and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration, and then I do the second while loop. Then I have the second iteration, and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows, the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements and I have a break command over here and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was, I was printing the value of n. So it was printing as value of n is 0, and then 1, and then 2, and then 3, 4, and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, so when I've executed this, I don't get the whole value of n is 0, and then 1, and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay. So let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement with the break statement. So this concludes it for our video on indefinite iterations. In this video, we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0, and if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again where we are going to multiply FAC. This time FAC stores the value 8 and we multiply it times the new number which is 7 now. So we do 8 into 7 and then again we decrement this. Also once we do 8 into 7, we store it back into FAC. And we keep doing this where we keep multiplying 8 times 7 and then we decrement the number variable by 1 and then we check this condition again. So what ends up happening is we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0 and then this condition will no longer be met. So number will be 0 and this condition will be false and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8 as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself where it will show you 8 times 7 or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate. And then the user would be asked to give an input which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first 2 numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now, in that case, we move on to this block. In this statement block, we initialize the fib variable with the first two Fibonacci numbers 1 and 1, and we store in this array. Now we are going to do a while loop within this, and in this while loop we're going to keep executing this statement block as long as this condition is met or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we're going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1, and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we're going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I, j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the 3rd row and the 5th column, or say the 3rd row and the 3rd column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the 2nd row and the 4th column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input 2 numbers, 2 integers, to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5, 5, that will be stored as an int in this particular string or this variable. What we want is, we want 5, say we entered 5, 5, we want 5 as a separate integer and the other 5 as another separate integer. And that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we are going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multi-list, which is basically what our final array is going to look like, and we're going to store into multi-list. And in this example, we will be using for loops to do this, or to create this particular array. So as you can see here, our first we have initialized our multi-list, saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multi-list will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion, where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3, 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So this is my final array that I get. So what you can see here is this is the 0th position, and the or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the 4th row, for example. 4th row times the 0, 1, 2, 3, third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. So this was it for these particular examples into while and for loops. I hope you found the 2 examples on while loops and this 1 example on for loops helpful to you, and I hope it gave you further insight into how we can use these types of loops in say different projects. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are 2 types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. Alright, so in Python we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, It is actually a list iterator at some random memory location, which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator. And in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now, what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other. And that is kind of how, or that is the basis for which we do, we create loops. Let's see what we exactly mean using this, using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter_a. Now with this iter_a, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth, now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned two things. What is an iterator, and how do we create an iterator out of different collections of objects like a list or a tuple, and we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. As you can see, some for loop with the objects again 1, 2, 3, 4, and 5. Alright, this is a list. Now I'm going to do for x in A, print x, and let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4, and 5. So first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in A, print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2, then 3, 4, 5. And then finally, on its own, like this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright, so think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration, alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally the third step is the termination step, is when after we do the final next, where we get this error, as you can see, the stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so Now I'm going to speak about, in specific, I'm going to speak about this something called the range function. That is quite, you could say it's used, definitely it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4, and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in X. Okay. Now let's do a type just to see what happens when we do type X. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in X print I. Okay. Let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is, when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3, and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator of 5 objects from 0 to 4, 0, 1, 2, 3, and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len A. Let's see what's going on here. First I do length of A. That gives me 5. Then I do range of 5. That creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, there are you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely and we will move on to the next piece of code, whereas the continue statement will break that particular iteration and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, let's create this dictionary. Again, we'll store it in A. Okay. So I created this dictionary A. All right. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type of a specific dict key iterator type. All right. So now let's do something on this. So as you can see in this dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has the value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore a print I. Let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore a. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is how to, this is basically two different ways of iterating through a dictionary, one through keys and one through values. So this concludes it for our video on definite iterations in Python. I hope in this video you understood and you learned about the concept of iterables and iterators and the different functions associated with it and how exactly the for loop function works in Python. In this video, we're going to learn about the topic called file handling. Now, file handling is basically needed because most of the times when we're handling large and different types of data in Python or in general, we cannot store everything into a variable and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now all binary files are encoded in a particular format and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now there are four main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file. And the syntax is as you can see here, where we use the open command and we give a file name and we give a mode and we store that in a particular variable. Now a mode is basically telling Python how to handle this opening. So we can have a read-only mode which is done by this letter R, a write-only mode which is done by letter W, and there are a bunch of other modes such as read or write mode which is done by R+, and we are going to see them as we encounter them. Now it's important to note that what I just mentioned is for text files. If we are going to do for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are three commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is going to, each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file. I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file. And what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these two variables are equal. So when I do this, I get my result, which is machine learning, which is the 5th line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in 2 variables. So it's basically 2 strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future or in future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store 2 particular file locations in 2 variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here. very similar to a normal text file opening. Now, once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image. And if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image. And my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that, we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that, again, you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of im1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function, and it copies an image onto another variable that you have assigned. And when I use the IMShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now, for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now, obviously, to define a class, we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now, after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now, you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now, any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user-defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are methods that we define, and these are like tasks that we define on our own. So in my user-defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now, if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, str it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of the what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, any time that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods, and this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now instance, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So Now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and each instance this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called myClass, and the second print statement is basically a string saying hello from the string name myClass with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class myClass in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like @class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called myInstance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the @static method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say .hello. It should basically print hello world. That's all. So guys, this was it for the introduction on OOP. In this video, we will be covering the topic of iterators. Now an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two values, two key value pairs, key x, which contains the value 1, and key y, which corresponds to the value 2. Now when I'm going to do a for loop through this, by default, I will be traversing through the keys x and y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects, and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of the, or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say this is, let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are like, they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. In this video, we will be covering the topic of modules in Python. Now, a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing the statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module. As you can see here, all of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now, a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these 4 functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I have to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from mycalc, we can do from mycalc import. Now whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract. for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way of importing something from a module. Now to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import mycalc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have two variables a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, and then the subtraction, multiplication, and the division of these two numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these two arguments or these two variables to say that I want to add these two. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import OS, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. In this video, we will be covering the topic of packages. Now, what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules? What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever we needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error, and this is because simply using the import command on a particular package only imports you could say the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly, and I cannot simply say import pkg and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this. So you don't need to bother about seeing me doing it right now, because I've already created these files, and what I've done is within mod111.py I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this, and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples, such as methods when we were working with classes and objects. In this video, we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here, I have defined a generator called myGenerator, where I'm doing like there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. Then I'm printing second item yielding 20. Then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know myGenerator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see, when we do next and we use gen, what happens. So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next. Let's do it once more, since there is one more task. There's one more iterable inside. You can see this. Now, a valid question is, what will happen if we do next gen again, since there is nothing after this? Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global. And the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright. And let's put a return over here after this particular, the second yield. Okay. Let's do the same thing. We say gen is equal to my generator. And let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration. And that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop, or for a for loop. So let's take this, what I have over here, and I have defined a function called getSequence up to x, and what this will do is basically it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say, sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0, and now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error, because that we have reached the end of our iteration. So this is a way of using generator functions for for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. In this video, we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to, so I'm creating a list over here, as you can see. Now within this list you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if, now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. Alright. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will you just basically need one line. In this case, it will just be like this. Now this is my string. Now let's see when I check what's in h letters. Let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this would, this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is X is going to take the value of 1, 2, 3, 4 and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number. And if this condition is met, that means we store the X into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each, okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are the even or odd, the first let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between like say the first 10 natural numbers, as I said. Now let's check if it is divisible by 2. Well, if it is divisible by 2, of course it's going to be even, right? Else we say that it is odd. And then we check for I in, say, the first, let's say the first 20. Okay. So now when we do this and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double x, this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking, what we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list, let's call it y. So now let's see what's in y when we check. It should be 0, 1, 4, 9 and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check. So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string, character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O, or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set, and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course, now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I, and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key, which is going to be like 0, 1, 2, 3. And the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2, 4, and then 3, 9, 4, 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user friendly. And also it's important to note that every list comprehension can be written in the form of a loop, but every loop cannot be written in the form of a list comprehension. And that is probably a very key point to remember. So yeah, that's it for this video on list comprehension, set comprehension, dictionary comprehensions. I hope you learned a neat new technique or trick when it comes to creating your new lists. In this video, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now the regex pattern or the regular expression module in Python can be imported using this statement, import RE. Now once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern, which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module RE, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this this command, we should get a perfect match. So we should be, basically it should say that search is successful if I execute this, and this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we're looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this dollar symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B, and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B, and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B, and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4, and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B, or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B, and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. Even though you might be wondering, like I can see an A over here, I can see a C over here. re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R-match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my larger string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now, if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string, and it will return us the first instance where it finds a match. Now let's see, this is the test string now, and we're searching again for we're searching for A, B, and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again, but this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now what if we wanted to find out all the instances wherever A, B, and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B, or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A, and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found 2 A's successively. So this is actually how findAll works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.findAll methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have 2 characters, like sets of 2 characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have 2 characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is 1 character. If we checked it with AC, it is a match because A and C are 2 characters. A, C, and D will also give us only 1 match because it will find A, C, and then it will leave D as a single character. But when we check A, C, D, and E, or this string in particular, it will find 2 matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using re.search for each of these different examples. So if you see when I use findAll on A, C, D, E, and when I'm searching for a 2 character match, you will see that it will return me A, C, and D, E, as you can see here. And similarly for something like this, it will return me again whatever like 2 character patterns it finds successively. So the next symbol, the next meta character, is the caret symbol that you've seen earlier. And the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not. So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we have already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N. And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately, or the N is preceded by an I immediately. And this is a no match because the strict condition in the search is that N must precede an A if the A exists. Again, in woman it will match because N follows an A over here. So we're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need M and A, at least one occurrence followed by an N. All of these conditions have to be met. So again, if we took the first example, M and N, this time it will be a no match because there is no occurrence of an A over here for preceding the N. So it's a no match. M, A and N is a match because, well, this is perfectly fine. M, triple A and N is also perfectly fine. But if you look at M, A, I and N, much like earlier, the N is preceded by an I and not an A. So there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1, only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases, only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, M and N is a match because there is 0 occurrence of A and 1 occurrence of M preceding N. So this is fine. This is also fine because there is 1 occurrence of A and M, and then it's followed by an N. This will not be fine because now we have 3 occurrences of A, which is followed by an N. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character A in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one A, and even this part of the string only contains one A. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 A's for 2 repetitions of A's consecutively. But this in the third example, you can see both the strings actually contain matches. So we get 2 matches because, as you can see here, there's 2 A's here followed by 3 A's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of A, but now we have 4 occurrences of A. But what the search engine is going to recognize is these first 3 A's, and it's going to see, okay, so there are 3 occurrences of A and I already have a match. It's not going to consider this 4th A in the search. It will just look at the first 3 and it say, okay, there are 3 A's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different, let's say, different meta characters, and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we are going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it will find 1 match. This basically this particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not because these are characters. But if you look at this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3 as you can see here. But now if you look at this test string, it's going to return me 12. It's going to return me 3, 4, 5 and 6. It's going to return me 3, 4, 1 and 2, but not 7 because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7 followed by 8 and 8 as you can see in this list over here. Now if we use curly braces with only 1 digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by X and Z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have two matches in this case. First an A followed by X and Z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an X and Z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an X and Z. And we can get that over here. We get B followed by an X and Z. So you'll get two matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves two purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these two examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that it should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.